Ah, I think we're live, mostly. So yeah, I really wanted to respond to Hoffleday's more lies. I think we're live. He's injustice a liar. Injustice. So yeah, I really wanted to respond to Yeah, okay. He's just a liar. Just a liar. Yeah. Anyway, it's a horrible liar. Anyway, so like somehow I've said something contradictory, or I've conceded something about changed some kind of opinion on the subject of Einstein's bent space, and the fact that it's a convergence. And he plays the Susskind clip, which I've even referenced. Suskind's obsession and this perversion where he calls it a negative divergence, right? Because he doesn't. He doesn't want to concede what it is, so they call it a negative divergence. I mean, physics using double negatives now, right? I mean, technically, that's all that is. Because pull doesn't make any sense, so they have to turn into a push, and a negative push. Oh, isn't that interesting? A negative push. Oh. Just such a crock of shit. And again, this is about their description of reality, not mine. I said it's impossible to make a rational model out of Einstein's bent space, and I stand by that statement. Hoffleday, by saying it's an abstraction, doesn't demonstrate anything but exactly what I'm saying. He's saying basically that reality is an abstraction. So reality, so they should just change the name. It should be called physics. It should be called abstractionism or something, because reality isn't physical, and it isn't it isn't even structurally mechanical. It's a piece of graph paper. That's reality. Reality is it's actually made out of numbers, abstract numbers, and graph paper or something. What a crock of shit. No, it isn't. Yeah, no, it really isn't. So what a fucking piece of work. Lying scumbag. So I should play his clip, but I'm on the other computer. I don't even have a link, so I don't want to go look it up. So I don't even know how to spell Hoffleday. What a scumbag. So the other jerk that via Apple, whatever, blah 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 blah, plays with his whatever his Greek names, whatever. He did a couple of videos on black holes, and it was just so bad. Black holes are matter that becomes too mattery and then disappears, but it still has gravity or something. But it loses its materiality, and it's something else used, some word. Yeah, but I mean, it's just, what are you talking about? Yeah, I mean, just silly explanations of reality. I would think he would argue that black holes don't exist, because I would think the fact that there is no real evidence of them yet, hard evidence of anything like the grapefruit kind of black hole. There might be heavy gravitational bodies, things bigger than suns, but there's no evidence that there's things not producing energy. But then they would be reflective, so I think we're still out of luck thinking there's stuff, heavy stuff, super heavy stuff. Yeah. And they're looking in, apparently there's some piece of equipment that who knows, I haven't analyzed I mean, you have to analyze everything now, but you can't trust these people. They make their 4-mile interferometers and tell you what they're capable of, and yeah, sure, I'll trust you. The inventors of dark matter, I'm going to trust. I don't think so. People who believe in Huygens, I'm going to trust. I don't think so. Not trustworthy kind. So anyway, what else do I want to get to? So I thought I would talk a little bit about the how you analogize, how you metaphor, how you describe uh, gravity, and what Einstein's field equations are really doing, and what's really happening, and why it's a little complicated to draw a picture of it, because it's got moving parts, which is the problem. And I guess part of my problem is yeah, I don't know if I drawing pictures and then showing them. Well, I can do that probably. I probably can do that successfully. All right, so what I'll first do, I think, is I'll just describe it as I think the sensible way to look at it is. All right, and this is one of those curious facts. I guess I better write down on my piece of paper here, curious facts. I gotta compile my curious fact paper because it's getting a little bit messy. So what occurred to me today was reflection. When light reflects off of something, the ironic part is that's actually when the energy is absorbed by the thing the light is reflecting off of. That's actually when, yeah, it's really absorption. Reflection is evidence of absorption, because what it's essentially, if you thought of it in the school of fish sense, so the school of fish is moving, or even if sitting still, and a fish comes in from this side, and a fish leaves going the opposite way. You could sort of understand that what basically happened was one of the fish inside of the school that was going that way left, and the fish going this way stayed. So the school actually is now moving. So reflection is acceleration. So that's when something's accelerating, is when it's reflecting. If the photon goes in and nothing comes out, that's when it's likely doing the opposite thing. The energy came right through it, or it went out some other way, but it didn't go out in the form of absorption, where it kept it as acceleration. It's more likely that it kept it as acceleration when it reflects. Reflection is evidence of absorption. So it's acceleration, and I'll put down evidence of absorption of momentum. So anyway, so I was thinking the real sensible kind of analogy for gravity is if you could think of a light that was the negative. See, the irony of Hoffley's video too is that a few days ago he made a video where he was talking about negative mosquitoes, and essentially Einstein's gravity, the bent space, is negative space. It's space that's disappearing. That's what's pulling the thing in, is the space is losing its space. So if you thought about it as a grid work, piece of graph paper, essentially what's happening where the mass is that the squares are all getting pulled in, which means they're either stretching or they're disappearing, and that the squares that are left have to fill the space. And so when a checker is moving through those squares, there's fewer squares. So obviously the squares are now pulling them in because they're getting pulled in, and it's over time, it's a moving model, and the movement is for squares to move in. So it's clearly that's what's happening. It's a convergence, and it's absorbing space. So it's essentially the negative mosquito, because we have no explanation for where's the power to eat the grids come from? Where's the source of the new grids? There's no answer to those questions. So there's so many ways you can analogize it. If you take the graph paper and you thought of velocity as the straight line, so when you're going with the velocity, it's all the linear lines would be an evidence, the size of the squares will be evidence of your velocity. So the smaller the squares, the smaller your velocity. The bigger the squares, the bigger your velocity. So as your velocity gets bigger, the number of squares you hit in the gravity gets less and less, obviously. So you can think of it in different ways, but obviously you have to just keep drawing it. With every movement, you change the equation. So with every square, you have to redraw the graph paper because the thing bending the space is also getting changed. The two objects are changing through feedback constantly, reacting to each other's changing acceleration and velocity. So, so that's what makes the equations complicated, is that they're moving equations. Stuff is changing through time, and that's the nature of calculus, basically, is to figure out a way to mathematically deal with those kind of problems. But it's a very complex problem in that sense. So, but what it really is, though, what it comes down to as a physical metaphor is a light bulb. And you could just say the equation would be complex enough to just have a light bulb. Okay, so let's call it a negative light bulb. That is, when it gives off light, photons, instead of the photons pushing you, giving you acceleration away, they do exactly the opposite. When a photon hits you, you move towards the light bulb. So you're attracted to it by every photon that hits you. And that's essentially the math. And the math is just figuring out your trajectory, how much it's changed. Your current velocity is going to be changed because you're going to keep adding these little photon hits that'll bend you down into the gravity, into the light bulb, theoretically. And if you're thinking about the well part, when you're going towards the light bulb, say the light bulb's over here and you're over here, when you're going towards it, it'll bend you towards it, but as soon as you get past it, perpendicular, all the extra speed you gained will you'll now use to leave the influence of the light bulb. So it gives you the strength, the velocity of the light you absorb going in is the energy you use to escape the light going out, so to speak, the pull. And as I pointed out, if you were to think of these two concepts of push and pull, you can do some reasoning, some logical deduction, and figure out that push is the simpler force, because push doesn't require a hook. Push just requires an impact. So it's a simpler thing to do, to push something, than to pull something. To pull something, you need to grab it. You need to hook it. You need to do something, where a push just requires contact. So it's more likely that this is a divergence, okay, as Susskind would say, except in the negative condition when there's matter present. So it is a negative divergence, which is in a sense saying the negative mosquito or the anti-mosquito. It's not really what's happening. What's really happening is there's an external pressure and it's pushing things into each other. It's quite obvious, and it's almost quite obvious from Susskind's reluctance to use the word convergence. And again, that reluctance is based on something. Why would somebody say something like a negative divergence? Why would they go to the trouble to say a negative divergence when we know convergence is really the first word? Convergence is the first word. Divergence is the second word. It's not the other way around. All right. I think it's just a concession to the fact that it's a push force. But anyway, so what you're mathematically doing is you're figuring out this is a truth of any force that comes from a center of gravity, so to speak. Any force emanating from a spherical or circular position will diverge, in the sense that the photons will diverge, and that's the inverse square part of it. Your odds of getting hit by a photon are inversely proportional to the distance in this r squared way, where you're cubing everything in a sense. It's the sphere thing, where every increase in the linear two-dimensional dimension would be a much larger increase in volume. So, and it's inverse, obviously, as you get further away from the light bulb, much less light hits you, more than just your linear distance. So half the distance, 4 times the degrade or intensity change in the number of photons that would hit you. So, so it's true of all forces that emanate in a spherical, in a whatever, peacock feather kind of way, from a central point, from a pinpoint force emanation, however you want to describe it. This will always be true, this inverse square thing. And all the forces match that. So the light bulb does it, gravity does it, magnetism does it, and nuclear forces, as far as they know, do it. So it's something that's true for all these forces. And the speed of light is also true for all these forces, which is another issue with the whole black hole thing and Einstein's theory that light has mass, because it really just doesn't work as a rational equation. You can sort of understand that light can't accelerate into bent space, into a change in the grid work doesn't affect light. It can't go faster into the sun. If I shoot a flashlight at the sun, the light doesn't go faster as it gets caught in the sun's gravity. And the same thing is true when it's leaving. It doesn't go slower because of the sun's gravity. That's just bullshit. And it's, they've stated this for years about black holes, that somehow light could be trapped, and they still say it with the event horizon as if you would stay in some sort of perpetual non-existent condition or something, and it's just nonsense. And it's only based on the fact that they play games with the speed of light and acceleration. All right, and mass. All right, so what else to say? All right, so you're doing the light bulb equation, and so the complexity is that you're moving. Here's the light bulb, the source of gravity. It's emanating these negative divergent photons, which mean the divergent photons cause a convergence, which means they will bend your velocity by accelerating you in one of the other perpendicular dimensions, and compound your total velocity, which now will be increased. So, but each time you change your position to the thing you're moving against, your proximity to the light is changed. And so you almost have to redraw the grid work for each new position to really do it rationally or correctly. I mean, I could have all the grid lines go like field lines and have them go back into the sun based on how fast you're going would be, how much bend there would be in all the grid lines as they come back into this gravity source. Just thinking about bending the graph paper, if you put a weight in it, it starts distorting all the squares. It's more than a distortion, though. It creates less squares. That's the negative space idea of it. All right, so that's really what field equations are dealing with, is the fact that this is constantly changing. Now, what makes it, which really makes it complicated, and why the equations are almost impossible to deal with, is that this object is also a light bulb. So it's producing photons that are pulling on the other light bulb. So the two light bulbs are inducing changes in each other's position and velocities constantly, and that's why the equations get almost impossible to do, and because those changes are just it's complicated. It's a lot of movement, and some of it is just about the movement of the center of gravity, technically. So it's just a distortion. The sun could stay in the same position. It's just like most of its mass could be on one side versus the other side of the sun, that kind of stuff. It can have a spin, different things. It can spin faster. Lots of ways that the acceleration can be realized that make it very complicated. So if you just want a simple answer, a general answer, well, then you go back to Newton, and you can do that. I mean, Einstein's just giving you Einstein's just taking into account the fact that there is a subtle impact, even if it's a small object. There's a subtle change, and it's a real change. But and again, Newton's equations always have to be, in my opinion, augmented. Because you have to always add the part about what part of the force are you attempting to measure. Are you measuring the force this thing is putting on this thing? Or are you measuring the force this thing is applying to this thing? Because they're not technically the same thing. And because they're opposite forces, they do add into one force, like the total attraction between the two objects. But clearly, they're responsible they're independently created, in the sense that they're two forces, two separate forces. And it's only through the trick of just rebalancing the equation based on mass to sit there and establish which one is going to do which by how much based on the force. So I just thought that was, I mean, I just figured it'd be better if Newton never did the add up the two masses and then proportionalize the impact on the two bodies based on their individual masses. I mean, I just think that's the equation should just say it in the beginning, that there's two forces and they're separate, they don't add. If you wish to add them, you can, but they're separate forces. All right. And the complex part is there separate forces that are constantly changing as the orientation of the object to the other object is changing. As it gets closer, it's changing. And so you can only give this force equation for any one set of positions. And so Newton's math essentially doesn't do the well, it can, but again, then it's just a complex equation, because now you have to integralize the equation over all of the over some average of the time elements. So you're basically just averaging. You're just saying, okay, let's move it an inch and then average. Move it an inch, take a measurement. Move it an inch, take a measurement. So you're just, and then you just average those out to get an approximation. But that's the best you can do. It's close, but not exact. Technically, I would imagine there's some margin of error based on the fact that you're averaging. Yeah. All right, so it's more complicated than I wanted to get, but I just want to get to the point that the real truth is that it is just a formula. Bent space is just a way of analogizing this light bulb metaphor. So it's just another way of doing the light bulb. I think the light bulb in the first place would be a more rational analogy. And then you just do the rational thing one step further and you say, well, let's get rid of the light bulb and admit that the real force is on the outside. So it's not a pull photon hitting you, it's push photons hitting you. And that totally explains the shadow thing and everything else. So it all falls into place. And it's the Occam's razor solution, and that it's the simpler force would be a push force. It would be more reasonable to expect the universe to use the simple force, not the hook thing. You know, that the rudimentary force would be a push because the push is a simpler force. Duh. So gravity is push, not pull. And the abstraction of Einstein's abstraction has nothing to do with reality. Reality isn't an abstraction. Reality isn't a mathematical formula. A mathematical formula can model the movements of things, and it can model the effects. So math models effects. So let's put that down. But it doesn't model relationships, the effects of rules. But it doesn't model reality. It doesn't model mechanical function. Okay, so Einstein's bent space is not a function. Space bending is not a function. It's a mathematical representation of the effect, but it isn't describing the actual cause. And as I've just pointed out, there's different ways of explaining the cause. So Susskind uses, I just used the light bulb. Susskind uses, say if you take a plane of water and you put a piece of glass on top of it so the water can't expand. So it's in between two sheets of glass. So the water has a constant depth. And then you put a hole in the glass and you push water in or you pull water out. It really just doesn't matter. That's the convergence. So from all areas, there would be, everything would move towards that center. Now that's his description, but it's his description of a light bulb. That's what a light bulb's doing. A light bulb is pushing, let's say, electricity in, and it's producing water that is the light bulb, that is the photons. And so it's the same difference. Exactly the same. They're just different ways of describing a mechanism that produces the effect. And my argument is the mechanism that's the truth, it can first be deduced to be, it's not pull, it's push. And it's quite obvious a push that's essentially a negative photon. Just essentially a real photon, not even a negative, it's just a photon pushing in, not a photon moving out. It's a, can't really call it a convergence. It's a field, any field of pressure, any active field will automatically create a convergence around an element that can absorb it or reflect it. I guess reflect would be the key word. So any object that can reflect the pressure will be pushed, quote unquote, evenly by the pressure until it's in the proximity of some other thing that's reflecting the pressure. And then there'll be a low pressure and they'll be pulled towards each other, which is really being pushed into each other. Math models are idealized versions of effects. Well, I wouldn't even say idealized because they're not. So, I mean, I wouldn't use the word idealized because they're often very inadequate, simplistic. They lack detail. They lack sufficient variables to account for all the effects. And so they can be very flawed versions of the mechanical rules because they don't have sufficient information in them regarding limitations. And that's why they get into, that's how they made black holes. Okay, is that they didn't obey any rule saying you have a limited source of light. You have a limited source of divergence. And, you know, yeah, it's okay. You know, you meant that. I'm just saying that, yeah, I just wouldn't use the word idealized because that's a little bit tricky. Yeah, you know, like I said, I wouldn't call them guesstimations because that's kind of, they're approximate models of effects. That might be being under generous, but I don't know. You know, but I think the important thing to stress is that math isn't reality. Math is only dealing with one element of reality, and that is the behavior. It's not dealing with the mechanism or the function. Well, I can't say function. It's probably the wrong thing to say because there's the rules of the relationship are what math is attempting to quantify, formalize. So it's formalizing the rules of the relationship. Maybe that's a way to say it. Formalizing the rules of the relationship. Of relationship, but it is not explaining the cause of relationship or the the origin of function. Okay, maybe that's a way of saying it. Good enough. Let's see, they simplify the problem so that the equations are solvable by eliminating variables. Yeah, that, again, I don't think that's a, I don't think they necessarily simplify a problem. I think when you don't have a working model, it's the best you have. A math model is better than no model. I guess I would argue that if you actually had a working synthesis, like an actual program that could actually run the simulation, that the simulation would be better than the math, right? I mean, it'd be more reliable. Simulations are often going to be built out of mathematical formulas, so that's sort of cheating. But I mean, it's like you could say, like the old abacuses, you know, different mechanisms for doing math were mechanical because the relationship exists in the mechanical relationship. So they duplicated the mechanical relationship. So you didn't need math You just needed the relationship machine, the machine that duplicated modeled the relationship. So I guess I'd still say that a real model would be better. A mechanical model would be better than a mathematical model, ideally. Yeah, having a real pyramid in front of you and measuring it would be, with a protractor, measuring the angles and measuring the length would be easier or more precise than relying on mathematical descriptions of those relationships, even as though some of those geometric relationships are rock solid and the math is going to be pretty solid. I'm just saying dependency on math, when it gets more complicated than that, injects a lot of error because the math doesn't account for things that are not physically possible. The math doesn't necessarily appreciate that a piece of steel gets weaker, a 3-inch piece of steel versus a 500-mile long piece of steel would have a different kind of strength, a different amount of whatever the word for that would be, rigidity. And a model might not be able to account for all the variables of heat and the material makeup of the steel and any magnetic fields in the area and blah 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 blah. Where the actual piece of steel and actually doing it will prove it one way or the other whether it's straight enough, kind of a thing. Well, whatever. I don't know what the Navier-Stokes equation, for instance, I don't know what that is, so it doesn't matter. I probably don't think much of it. Doesn't sound like a good thing. There's so much to doubt just because you find out how many times physics has relied on crap, and you're just saying, wow, that was crap, that was crap. You got Heisenberg going way back in terms of a piece of crap. Just a made-up axiom that the photon has no position. Not that it's an unmeasurable condition, but just this statement that it isn't possible. It doesn't actually have it. It's not that we can't access the information. It's the information doesn't exist, and stuff like that. And then you get the Huygens, and then dark energy and dark matter, and there's just so many made-up elements of so much fudge that you can't trust any of these equations. You can't take anybody's word for it, and I personally can't. Some I can't do anything with because I obviously can't do that kind of strangled math. I can't do tensors and blah blah and all this other shit. I need to get more fan in here. It's hot. Just a minute. Ew. That's better. Oh, cat. I'll be back. Oh, no cat. Anyway, so I didn't draw anything, which is nice. Yeah, spared that headache. Yeah, so I think I've mainly done what I wanted to do here. Like I said, I just want to, Huffleday is just so irritating. To imply that I've changed my position or in some way concede any of his points, which I do not. I never said Einstein said, space is a curved fabric, and that's all it is a curved fabric, and that's what it is in reality. Or I never said anything. I always said these are metaphors being used to describe Einstein's bent space. And I pointed out how they're lousy metaphors because they don't come close, and they don't work in 3 dimensions as anything but perpetual energy. And it says that you're moving mass with no force. And that's, I would argue, a violation of physics. To pretend that space is doing is obeying a mathematical formula is just, in my opinion, just idiotic, and that somehow the space actually has hooks, or it actually has a pushing thing. I mean, that it can actually do push or pull with no physical mechanism, I think is just crap. Especially, again, when it's just a metaphor for a light bulb. The force you're describing with your bent space is as simple as the mechanism of a light bulb emitting photons. The basic mechanism is just that simple. And if you just make both the light bulbs interacting, now you understand why it's a complex equation. But the basic mechanism is exactly the same. So there's no reason to create a fake dimension of space-time in which you perform this simple function of accounting for a force, describing a force. Yeah, well, yeah, I don't know what to say about the fluid thing. Gets a little dangerous. Like I said, if you, it's like I said, even in the Susskind analogy, what you end up having to do is you have to confine the fluid, right? You have to make sure the fluid can't expand in volume. You have to, so you have to create rules for the fluid dynamics to be anything like the physics dynamics. So I'm not saying they're both mechanical things, and obviously it makes sense they have something in common, but obviously I think you can kind of understand that fluids are, I mean, you could say, like, if I took a bunch of BBs, I can, for certain actions, I can make the BBs look like a fluid. They'll behave like a fluid. But in certain other ways, they won't, because they have no adhesion. So, unless I make them magnetic or something, they won't behave like a fluid, because they don't have the same, they're not bound by the same force intensity at their level of size. So now we're back to this thing, like it's an interesting subject, I think. What defines the limitations? So it just sort of gets to the black hole argument. It gets to the speed of light and what that means in terms of implications for total amount of gravity in the universe. So what is the size limiter? What prevents suns from getting really, really, really huge? Like the size of a galaxy. Why are there no suns the size of a galaxy? Right? So these are the simple questions you could ask. Why no sun the size of a galaxy? So why do solar systems? So why no suns even? I don't know how big suns get. So maybe there are some suns as big as a solar system, our solar system anyway. Maybe. But yeah, why? What's the limitation on size? What's the smallest galaxy you could have? What's the biggest galaxy you could have? And why? Those are the interesting questions. And they come down to, again, I think, how you quantize You know, what do you use as your fish? You know, what is the real fish of the universe, and what's the consequence of the fish? You know, their ability to function. So, and you know, what establishes, you know, once you have, you know, this question came up in the last video, but you know, the existence of matter. I mean, what creates it? How do you create an atom? Create an atom. I'll put that down. Or how do you create a proton, even a neutron, an electron? Why are these things special? And are they only, is their power the fact that they have the default condition? So once they exist, they're hard to erase. So it's like a it's like dye in a fluid experiment. You can put dye into a fluid, you know, like a thick fluid, and then you could spin the fluid, and then you can reverse it, which is really quite interesting, right? So you could spin the fluid, end up mixing the dye, and then if it's, you know, if you have a thick enough suspension, you can reverse the number of spins and get back the one drop of dye again, which is really interesting. So where was I going with that? Yeah, so the default always has power. So you could argue that once matter exists in an arrangement, the field has a hard time breaking it, because to break it, it needs to like hit it with 5 fish from one direction or something. It has to have a hurricane to knock the tree down, or I don't know what to metaphor it with. But yeah, once it establishes its default, once the default exists, it doesn't easily change, because any change you make to it ends up in the local field, and the local field tends to recycle back into it again. So it just tends to regain what it loses, to restore a balance, which is the default. So once the matter exists, it becomes the default, kind of. But I need more than that. I need more than that as an answer. But I just think it's somehow related to that probabilistic default. That once it, like if I had put a dice down with, you know, showing a 5, I've essentially now, when I roll the dice, I've already used the 5, technically. You know what I'm saying? In the probabilistic equation, 5 now has an advantage, so now I should be rolling less 5s because I just used one of the 5s, so to speak. All right. So yeah, so that's going to be a sticking point for a little while, because I have to figure out why field energy behaves differently than matter. Because I'm arguing essentially that matter is just an arrangement of field energy. So it's just a collection of force, and there's no overt reason, obvious reason, that there should be a difference between the force in matter and the force outside the matter in terms of interaction, because there's no forces don't affect forces. So we know that, right? Can't affect a force with a force. I can't affect light by shining light at it. Can't affect force with force. And you know, there's this slight indication that you can affect polarization of light by transmitting it through a medium. and then distorting the medium with magnetism. But you're really just affecting the medium, not the force. So again, it's matter affecting the force, not the force affecting the force. So that gets a little difficult. Yeah, well, I mean, the question mark you put there is, what I'm saying is you can't bend the magnetism with magnetism. You can't bend light with light. You can't bend light with magnetism. You can't bend light with gravity. So I'm in spite of the bullshit of Einstein, you can't affect any of the forces. So any ton, graviton, magneton, photon, any of the force moving at the speed of light doesn't appear to be affected by interaction with any other force. No force affects a force. A force will just travel through another force. Magnetism will travel through light. Light will travel through light. How else to say it? Yeah, well, I'm saying magnetism travels through magnetism. It doesn't affect anything until it reaches some sort of matter, and then it affects the matter. But it can't affect the actual force of the magnetism. Can't change the magnetism something else is emitting. You can only add magnetism. Can't really subtract it. But that might be. But see, yeah, it adds and subtracts because the two magnets affect each other. So I mean, as soon as I put two magnets in proximity to each other, they change each other's magnetic structure, which changes the external field. But I can't make a magnetic field change a magnetic field. I certainly can't use light to change magnetism. I can't use some other force to affect a magnetic emission. I can't suppress magnetism with gravity or light and radiation. Just there's nothing I can affect magnetism with except affecting the material emitting the magnetism. Feeding the cat. Ugh. Yeah, sorry, cat. Midnight snack and such. Anyway, hello, I'm a fan of your DraftScience videos. Yeah, I gotta fix the DraftScience channel. Actually, it's the website. I think it's down at the moment. Yeah, I gotta fix that. Gotta write that down. Fix website. Lots of stuff to fix. Change the server. Everything's fucked up. So where was I? Yeah. So yeah. So those are like the interesting questions. Are trying to find a way to explain the creation of matter, and therefore the function that allows force to affect matter, reflect off of it. So reflect is the interesting. I think that's the winning statement of the day, is that reflection is absorption. You know, that when force reflects off something, it means the object actually absorbed the acceleration. It exchanged a fish going that way for one going that way, you know, that way for that way. Gave back the wrong way, kept the right way. And in the case of devices made to do so, it changes the movement into some sort of perpendicular movement, which would be electricity. So like a photovoltaic cell is taking the energy coming in perpendicular this way, you know, towards it, and converting it into electricity going this way. Yeah. So what else? Yeah, so I'm just stuck there. So I have to, that's still a problem to figure out. But all that's really happening, I said, the bottom line is what I'm going to argue is that what's really being exchanged is polarization. Is that we see things based on its polarization and whether it has a frequency. So we see a reflected photon because it's reflecting at the frequency. You know, they're being emitted at the tons have a separation, a frequency that's visible. But there's always stuff reflecting off of everything constantly, and it's just at a frequency our electrons don't detect. So most of the force does pass through matter. So most of the time force doesn't affect force, and it's only this special circumstance to be described. An angle, the real argument, I guess, would be is that angles happen inside matter, angles of impact, of interaction. Happen inside matter that don't happen in empty space. And that's why matter is necessary, that don't happen in free space, we'll say. So force interactions at specific angles happen inside matter, and those interactions can happen in free space because it's more geometric, let's say. It's a different geometry. So the geometry of inside the matter is enough different that it allows for interactions that can't happen in free space. Yeah, so that might be it. It sounds a little bit, maybe. 8.9, that's a big one. Yeah, well, it's not going to be close enough to cause a tsunami. I mean, unless it's way off the Oregon coast. You know, it has to be pretty far to, it has to be in the deep water, you know what I mean? And it would be pretty far. I mean, the further out it is, the better it is in terms of the earthquake, because then the land mass won't be shaken as much. But the closer it is, the less you would already had your tsunami, right? I mean, it have to be, yeah, I mean, really, it doesn't take, you don't have to go very far away from the epicenter for an earthquake to degrade pretty rapidly. It's kind of like gravity, you know, I mean, it's inverse square kind of a thing. What the hell is that? Something in my damn house. Be back in a moment. What the hell is that sound? What are you doing? Who gave you permission to go out there? Huh? Yeah, nobody told you to go out there. What the hell is that sound? Jesus Christ. Some kind of monster under the house. Oh, it's some numbly numb. Jesus Christ, you stupid fuck.
What?
You're making noises. I'm fucking a fucking monster in my fucking house.
I didn't catch any of that. Did I scare the shit out of you?
No, well, it wasn't really shit that came out, but I just thought it was like a raccoon or something under my damn house.
What? Why?
Well, because that happens. I live in the woods.
No, but I mean, what sound could I have made coming in here?
You were making all kinds of fucking sounds, your fucking submarine sounds and shit. Whatever you were doing.
I just clicked into the room. I don't think I did anything. But are you hearing submarine sounds now?
No, but there's always a little bit of an echo. But I'm just saying you make noises. I'm just saying that no matter what you're doing, you're a noisy person, apparently.
I think it's just that my microphone has been turned up too loud.
Yes.
I turned it down now, so I think it should be better.
And it's still too loud for me, but I'm going to turn the volume.
I'll turn it down a little more.
I'll turn my volume down also. So that was part of it, was yes, whatever sound you made was amplified, so it was really loud.
Okay, how's that?
Okay, that's better.
Okay. Sorry about that.
Anyway, all right, there, I'm back.
I can't hear my own volume, so I'm not aware of these things.
Well, I know, but you can always learn by experience, because you can hear how loud you are in a room and say, yes, I'm as loud as everybody else, and then you say that's a good volume.
Well, that's what I'm trying to do now.
Okay, that's fine. I can't say my settings are correct at the moment anyway, because if I was playing, I might have been playing a Holiday video the last time, and so I always have to crank the volume way up because this fucking idiot still hasn't figured out how to make a video with the proper volume.
Well, he mumbles anyways. It's pretty hard to understand.
Fucking lying cunt idiot.
I think you've become an expert interpreter of his mumbling because I can't pick up half of what he's saying most of the time. Like, he's got a weird accent, he mumbles, and he's way too quiet. It's a bad combo.
Well, he's stupid, which is also bad. And he's totally inarticulate, and he's totally a hypocrite. And, I mean, the last argument he just made was basically he's just arguing that reality is an abstraction. That reality isn't a physical thing with physical properties, that it actually is a mathematical equation. I mean, it's just such a fucking idiotic argument to make. Life is, the universe is abstract. It's just it's a cartoon, I mean, it's a drawing on a piece of paper somewhere. It's not a real thing. I mean,
that's like the Pyrrho argument.
Stupid.
It's an information theory.
Yeah, I watched listened to some. I mean, I jumped through the Pyrrho room because it's just too long. And I caught the little bit where Vic was harassing you because you're not a scientist. I mean, I know that went on for like an hour or something. I don't know how, it seemed like an awful long time. And he's just nagging you that you're not allowed to say you know anything about physics. And you're just saying this is coming from Vic. What's Vic's authority? Where does he get his authority from? How can he judge? How does he know? And where in the history of science has this ever been true? You know what I'm saying? I mean, what Benjamin Franklin didn't go to fucking the Institut Technical or something. And he was one of the best scientists ever. Yeah,
well, Vic Mackey's a retard. He really is. The guy's a fucking idiot. He thinks he's smart. He really believes he's smart, but he's really fucking stupid. He just comes up with fallacious arguments. Everybody thinks this, and you're not the authority. That's his argument about everything.
He's just terrible.
Guy's a moron.
But anyway, it was just, the room was always a waste, but it was especially wasteful this week.
Yeah. Well, I got out of there pretty quick after that, but geez. Yeah, it's pretty abysmal. It's pretty amazing that you could have that many people being that stupid in one place.
Yeah, and you have to have an argument about, well, what are you saying? I don't have a right to have an opinion? Or what? You're saying my opinion doesn't mean anything in spite of my evidence and in spite of the fact that you haven't proven me to be routinely wrong about anything? I mean,
Yeah.
shouldn't that be the standard? I mean, that's why I'm doing this room. I'm basically saying, look, assholes, here's your chance. Prove me unreliable. And
Yeah.
Hathaway thinks he's done that, right? He thinks he did that by saying, somehow I've admitted that I was wrong about Einstein's bent space, which I wasn't, and that somehow I'm conceding that reality is really an abstraction, and I'm not doing any of that.
Mhm.
So but he's always declaring victory, like he has now caught me, and he's now revealed how I was wrong about something, and I'm just sitting here saying, again, for the 900th time, what was I wrong about? What did I say that was so egregiously foolish?
Yeah. Well, I get the impression that those guys don't spend much time listening, you know, because it seems like they almost see themselves as sort of emissaries or mediators of the, you know, liaisons of the mainstream thing, and they're trying to come up with some kind of compromise argument or something, but it's like they're not arguing they're not arguing against your argument. They're just
I mean, it's just kind of funny. I mean, I called the channel Draft Science, right? I mean,
yeah.
I'm basically arguing that, yes, okay, this is, you know, let's look at this stuff, let's examine it. And, you know, maybe I'll say some things wrong, but I'm just saying that I'm even arguing that, look, the few mistakes I've made have been, yes, okay, I've made some mistakes, but I mean, there's nothing catastrophic here. And so why am I not a credible, why don't I have a right to make an argument? I mean, they're all just saying I don't have a right to argue the argument. I don't have a right to argue that the evidence is inadequate.
Yeah.
I mean, how can they deny me that right?
Right. And mistakes are okay. It's integrity that's important, right? I mean, if the willingness to admit the mistakes and review the information, listen to arguments, that's what the mainstream scientists don't do. They don't listen to
It's hilarious because, you know, Halfway was saying something too about something like that. And it was like, oh yeah, he keeps posting this new guy, this Iranian scientist guy with the bald, you know, going bald, and he keeps trying to pretend it's not happening. And he's got like the dirtiest, ugliest hair on earth. But anyway, you know, he's one of these string theory multiverse loonies.
Yeah.
and it's, you know, and now he's talking life theories or something and blended into physics, and it's just such a crock of shit.
Yeah.
But what's the major? Why did I bring that up? So you make some point about what science is, and you're just saying, oh yeah, that the physicists are willing to listen to anybody, and you know, it's just so ironic in the terms of the harassment you were getting, because this guy is basically arguing that you know, physics wants some amateur to come up with an answer, and it wants any good idea, and it doesn't have any interest at all. You know,
Yeah.
it has absolutely zero interest in a new approach or a new idea. None.
Did you happen to watch the video that I linked in the comments of the last video that you made? Because I found a video where there's a Nobel Prize winning physicist who basically is right on about, like, he's got the right idea about dark matter, and he explicitly says dark matter is a religion. And then they're interviewing some grad students, and it's actually like the only video I've ever seen where two Nobel Prize winners like are going at each other kind of almost properly. And then they're interviewing these grad students at the end, and the girl says, well, I believe in dark matter because if I didn't, I'd be out of a job.
Yeah.
She says that. You got to see it. It's just.
Yeah. Okay. I guess I haven't gone through the comments on the Draft
That's
Science channel, but I'll take a look.
Yeah, I'm just saying, if you get time, you should take a look, because I think it's when you just see the general, like, this video is just a lot more candid than anything else I've seen, I think. And it's, you know, because they're all like, it's these grad students, and then this one complete moron scientist, and then this one guy who's got the right idea about dark matter and stuff like that, and it's so uncomfortable. It's such an elephant in the room. Like when this guy, he's like, I don't think dark matter exists. It's this guy. His name is Martinus Veltman or something. He's a German scientist, and he's famous for work in particle theory. But I thought it was kind of refreshing to see that he was actually just not even arguing against it, but putting it in its place.
Yeah, well, it might be the kind of guy to email,
Yeah,
I know of one other guy who's like that. He's a professor at Cambridge, I think. So I have to try to contact him anyway.
Mm-hmm. Unfortunately, I tried to look up more material from this Martinus Veltman. I think that's the right name. Anyways, but all his videos are in German, unfortunately. So
yeah, that sucks.
Yeah, someone's got to
have to find some
papers. Perfect English, so someone's just got to get him on an English forum.
Yeah, maybe you can find some, PDFs or something.
Mm-hmm.
Some of his published papers.
Yeah, well, I'm sure that those are probably available, but I don't think his published papers include much of his opinions about cosmology because his work is all in particle physics, right? But just the things he was saying, and I guess it's partly because he's not in that field, so he doesn't really feel like he owes them anything. But I mean, he was, he just was saying the kind of things we'd say about it, like.
Yeah, well, I mean, it'd be interesting to see somebody who's in particle physics, arguing these points, just because it seems to me that even particle physics has a huge number of dark matters in it.
Yeah, well, I'm not defending his.
I mean, I wonder what his opinion is on the whole boson bullshit.
Yeah, I don't know. Like I say, I couldn't find his actual material, and I suspect that he's not necessarily right, but he was right about that topic, and he's a Nobel Prize winner. So, I mean, he's a Nobel Prize winner saying dark matter is a religion. That's kind of cool.
Oh, I'm not saying it's not cool. I'm just saying
it
would be interesting to see if he has consistency in the sense that he also points out how they're drawing an awful lot of conclusions in the standard model based on really weak evidence of any kind of coherent interaction between these particles that only last a millisecond. So it's kind of a cheap way of describing reality to say, these things have durability, but they're, not in, not when we take them out of the car, kind of thing.
Right. Well, that whole field, the experimental side of that field, from what my probing into it is very opaque. They don't publish their results at CERN, for instance, so that's kind of a problem, right? Like, you can't see anything.
Well, I mean, they could publish them because they're all statistical analysis of 5 million zillion photographs, computer analysis of a zillions of these, even mathematical, pictures that aren't even converted into pictures. You know what I mean? They're just digital representations of a circumstance, a millisecond in time.
Right.
So, it is kind of, the data set is kind of not real data. It's all wanky computer data.
Right. I mean, I can't personally give any credibility to someone who doesn't show anything. Like, I mean, the whole field is so rife with this, with these problems that, like you were saying earlier before I joined, they have to prove things to me. Like, they need to prove it. Like, why would you take their word for it? They're
exactly. Well, it's
terrible record.
The whole gravitational wave thing. What exactly is their theory that they've got in their computer every possible aberrant sound?
Right.
How do they figure out they have that? They have a true sample of all the sounds the universe makes.
Yeah. Yeah. What is the
Where did you get that from, God? I mean, who compiled it for you?
Yeah. Like, what's their baseline? Because there's, they kind of are indicating that this thing is never free of noise. So,
well, what to say? You're just basically saying what? So you just wait for a noise that isn't in your database, and then you say it's a black hole doing something.
Actually,
so every fart that you haven't identified is a meaningful fart.
Well, actually, it's funny because I read this in this the last video that I saw about that, the way that they described that, the way that they arrive at their results is that, no, it's got to be a sound that they do know. They've modeled like 200,000 different little waveforms, and then they run their results against prefabricated things that they've conceived out of whatever, you know?
Well, I know what they have to do, some kind of narrowing, because obviously there would be so much noise. But that's what I'm just saying is that they're saying they're looking for something cat-like, you know, and then they go out into the jungle and they have no idea what's out in the jungle, right? And they just find whatever is cat-like or something. You know what I'm saying? Anything that fits cat-like, and they just say, God, that's it. That's a black hole. That cat's a black hole.
Yeah.
You know,
the 1 billionth of a proton.
It matches what I'm looking for, you know.
Yeah. Yeah, and then it's the 10,000th of a proton cat, right? It's
I don't even get into this. That ludicrous, you know, we can tell how thick a piece of bacon is on the surface of the moon, you know, or whatever that shit is, you know.
Yeah, and then when you
fucking silly.
Yeah, it's there's like, what's the range of error on something like that? I mean,
well,
it's just complete garbage. I mean, you know, like I said this when that happened, and then I went on the Puro chat, because it really that really killed any remaining hope that I had that these people are doing anything good with the money.
Yeah, no, I've really been, you know, like I said, it was really quite a shock to me to find out that you know, the Einstein lensing thing has never been, as I can find, in any way ever verified with anything called a real experiment. You know, ever. You know.
Yeah.
Nothing. There's no evidence the sun has ever bent a piece of light ever, you know.
Yeah.
And you're just like, wow, you know. I mean, you just go back and you just say, shit. You know, and then the Huygens thing was another huge wake-up call, you know, because I kept hearing it in all these physics lectures. And I'm saying, okay, this must be a real thing. They all are talking about it. Every single physics lecturer guy is talking about this Huygens thing. Yeah. And you find out what it is, and you say, well, so this is just an excuse for you to split the photon in two.
Yeah.
And you won't use it anywhere else. So it's a principle. And yet the only place you're ever going to use Huygens is when you're going through a single slit. You'll never use it anywhere else in life. It's completely irrelevant everywhere else in the universe except when light's going for a single slit. Then it needs the Huygens.
Yeah.
I mean, that's some principle.
Yeah. Well, it's the map. It's the map and the territory thing again, and that's the fundamental problem. Is that they're like, well, we can't get to the territory, so, you know, we're just going to take the map for the territory, and we're going to call it the territory. And it's like, they just unwillingness to...
Well, I know, but I mean, this isn't even rationally put on a map. You can't rationally put something on the map that's not a consistent, you know what I mean, that you don't use anywhere else. You just use, it's like a, I mean, it's like dark matter. It's just so obviously glue. It's
well, yeah,
in there for the mere purpose of fixing the fact that your map doesn't work, that your roads aren't connecting, and so you're faking a fake bridge. You're just making fake bridges that don't exist, and you know they don't exist.
Right, or you could see it as like, you know, something added to the map for orientation purposes, like lines or borders or something like that. I mean, they're including the borders as part of the universe. You know, it's that kind of thing. Like they're adding extraneous factors that they're permitting themselves that are map stuff, not territory stuff.
Yeah, well, I'm just saying it's not a map. It's not a description of the reality. It's a contrivance of
a description of the map.
It's a duplication of the destination. It's not a duplication of how you get to the destination.
Right.
You know, I mean, it's just not, you know, it's taking a boat that doesn't float, or it's not a submarine, you know, it's an airplane, and calling it a boat. It's an airplane. It's not a boat. You know, it's just wrong.
Yeah.
To say you had a nice ocean voyage. You know, I just took the Concorde. You know, I don't fly that anymore, but you know what I mean.
Or it's like steroids or something like that. You know, it's some sort of performance enhancing bullshit that, or so-called, whatever, some kind of fake device that they make themselves look good. They look like the muscle man, but they can't fucking lift anything.
Yeah. So anyway, it just does make it that much more difficult when you can't trust any of it. You know, where you have to actually sit there and go through each one of these experiments and figure out exactly where they have pretended they know this works, pretended that they know how much the mirror distorted the light, or how much the lens, you know, how many times the photon was, you know, the wave thing was collapsed. You know, how many times did the wave get collapsed in the lens?
Yeah, but on the other hand, think about how much is there for the taking if you can actually get the argument heard, right? Like there's so much, it's wide open.
Well, I know, but it's always been wide open. That's the part that's scaring me, right? Because as I was just pointing out with my analogy for gravity, is that it's this, I mean, even in the days of a candle, you could kind of get it.
Yeah.
You could just say, well, what if I reversed this effect? You know, what if the candle wasn't producing something, but was a place where the something went? You know, wouldn't that be duplicating exactly what gravity's doing? So I'm just saying the fact that they knew that if I put a candle 4 feet away from me, you know, half the distance is twice as bright.
Yeah.
You know, they you know, it's the same thing as gravity. I mean, how could they not make this obvious connection that gravity's got to be the same kind of straight line force?
Right.
You know, what else? How could you say that's not just? I mean, it's just like, yes. Well, I mean, it's like, even if you had no other evidence, the fact that OJ had a vicious cut on his finger the very night that his wife's head fell off. I mean, it's just a kind of coincidence where you say, gee, I mean, how often does that happen? You know, you viciously cut your finger with a sharp, straight blade of some kind on the very night that your wife's head flies off.
Yeah. Or
gee. You know, wow, isn't that amazing?
Or it's like claiming that some particular species that has DNA has some completely separate origin. Like, it's like they find some life form, they're like, well, it came from space and it just has DNA. But you know, we know it's from another planet, even though it has the same DNA as the creatures on this planet.
It's like the arsenic, you know, bullshit from NASA.
Well, you could look at it like that, right? Like they all have this DNA of this same behavior, so that links them together fundamentally.
Well, I'm just saying that they have that in force. It's just sitting there, like I said, and then magnetism came, you know, even with that, you know, you go back to Maxwell's equations, you know what I mean? He's already pointing it out, and instead of doing what he should be doing, which is saying light is behaving like magnetism, you know what I'm saying, like gravity, he does exactly the opposite and turns light into a wave. You know, and you're just like, no, you went backwards. The other shit's not a wave. You know.
Yeah, it's a clusterfuck.
Yeah, sure. But I'm just saying it was already there to be had. So you're just saying, you know, with all this time that nobody has challenged this, and I find it hard to believe that it needs me to do it. So there must be something. I don't know. I don't know. It's just hard to imagine how. They're just a lot dumber than I guess I thought. I mean, these scientists are really full of shit. They're very good at they're like idiot savants. You know what I mean? They're good at counting toothpicks, but they really suck at everything else.
Yeah. Well, I think that it's gotten so built up that for them to admit the whole thing was a mistake at this point would just discredit the whole field. So nobody wants to be the guy who discredits the whole field in his own time, and that might pose.
Well, I know, but I mean, they really would want to be the guy who actually gets it right. So I just think that, I don't know. I can't really buy that either. They obviously just don't have any imagination. I don't know what I don't know. I really can't explain it, because it does seem glaring, and I don't know how. I mean, it really shouldn't have been possible for me to sit there and part-time, you know, a couple of hours, what 10 hours a week, you know, and 4 years at 10 hours a week, you know, to unravel, you know, this much bullshit.
Yeah. Well, you know, I think ultimately, like, you just you know, that's not your responsibility to explain why they're wrong, other just that they're wrong, right? So I almost think it's just a topic almost to be avoided, because like, you know, I keep wavering back and forth between like they're stupid, they're in the group herd mentality, or they, you know, this is
Well, I know,
conscious.
but you do kind of have to deal with the fact that you know, as you know, you have this thing with the conspiracy theories and whatnot. You do have to deal with the fact that you're in a class of naysayer essentially, and that class is full of idiots.
Well,
You know, so I mean, I have to, you know, I'm stuck with the fact that it's like that Theodora, whatever his name is, you know, the photographer guy. I mean, he's so full of shit. It's like, oh yeah, so that's what the anti people are. You know, they sit there and call Einstein an idiot, and you know, Tesla was the most brilliant man in the history of mankind, and it's, you know, you're just like, you know, so this is what you're stuck with, is your.
but are the physicists any better? Not really, right?
Well, I'm not saying they are. I'm just saying that the problem is that I obviously have the default liability of being the outside class, and the outside class does look like a bunch of lunatics.
Well, you
They
can't
all
really.
have perpetual motion devices. They all have some
Yeah.
kind of wacky, stupid unicorn bullshit. And you're just like, man, their explanations of physical reality are more preposterous than the Einstein silliness. And you're just saying, wow, they figured out Einstein's silly, and yet they haven't figured out that, you know, you can't talk about a lack of inertia. There's no such thing as a lack of inertia.
Well, that's why
nothing can lack inertia.
that's why my position, the position that I've decided to take on this is that fuck it. I'm not going to theorize about, you know, I mean, I think.
Well, I agree. I'm just doing it just because it seems an obvious thing sitting in the room is the fact that,
yeah,
you know, this was doable.
Yeah.
By somebody besides me. That's all I'm saying. It was, you know, this didn't take a really smart. I didn't have to be really brilliant to do this.
Yeah. Well, you know, or not. Maybe not. Maybe you're not giving yourself enough credit. Who knows?
No, I'm just saying it really wasn't that hard. You think, oh yeah, okay, let's see this gravity thing. Well, what if, you know, gravity's moving the same speed as light? Well, what if gravity's light? And as soon as you do that, doesn't it start to, oh yeah, okay, well, what if light was at a frequency I couldn't see?
Yeah.
You know what I mean? That's a simple thing to say, but just what if you couldn't see light?
Yeah.
How would you know it was there? Wouldn't it be just like gravity? It could be all around you right now, and you'd never know it because you can't interact with it, right? So if you can't interact with it and it goes right through you, isn't that gravity?
Well, that's a very good point.
So I'm just saying that's where it started, you know. And the last 2 years of videos, haven't they just been I went from that simple thing, and it went through every bit of physics and just tied it all together, you know.
Right.
Explains time dilation, explained everything, inertia, and all of it.
Yeah, well, that's what a good theory will do, right? It'll just spit out a lot of other good theories. That's the sign of a strong theory, is that it produces more theories.
Well, it produces more consistency, I suppose.
Well, more good theories, right?
Yeah,
like
it fixes all the errors. It gets rid of all the stuff that the rest of it is broken by. You know, because it just cuts right through all the error code.
It's like if you can theorize evolution, then a whole bunch of other crap just becomes clear instantly, and then it just takes people sitting down and working through it. It's no longer rocket science. It's just a matter of
you don't have to keep asking, well, why did God create that, and why did God do this, and why did, you know, because now it's, you got one answer. Is that, you know, it's you can find the mechanical history. It had nothing to do with why. It's just a how question.
Yeah, you just got to get a foothold. You can start climbing.
No.
But yeah, I guess like the problem, it's just such a log jam of these retarded ideas that you just can't. There's no air in the room for.
Yeah, well, that's the problem. It's just so hard to get to the argument, right? So you can't. If you argue with these these pseudo intellectual type who think, you know, they know something. They just disqualify you.
Yeah.
Right. So you can't argue with the Piros or the Vicks or, you know, any of the assholes in that room even, you know, because they're all just naysayers. Whatever I don't know must be super hard to know. That's almost their attitude, right? Well, if I don't know it, it must be super hard to know, and you can't know it.
Well, or Vic's argument is like,
Gary
thinks that. Gary thinks that's what. That's his argument. Gary thinks that.
You're just like, wow, that's a great counter argument. So you sure owned me there, didn't you? You just absolutely demonstrated how I'm the one full of shit, yet I'm not the one who has absolutely no evidence for the shit I'm arguing.
Yeah, well, they just argue in this character assassination angle, right? They're like, well, Gary.
And how many times have I said, I accept all of Newton's math. I accept all of even Maxwell's math, as long as you don't use it for light, you know, because it only applies to light when it interacts with an electron. So outside of that, Maxwell's equations are cool. Yeah. How many times have I said that stuff? And then people say, he doesn't have any math. I'm like, what do you actually want me to just duplicate their math? You want me to just, and then I'll sign it? You know, I'll just write down Newton's equations and I'll put my signature on it. Is that what you want me to do?
Yeah, I have to say, after arguing with Vic Mackey yesterday or whatever it was, that guy is really a fucking idiot. Like, he's worse. He sounds smarter than he actually is. Like, somehow, like he sounds, 10 IQ points higher than what he has. He really just has nothing. He's just got nothing.
Yeah,
he's a fucking fool.
So, I mean, but that's what makes it really hard to get off the ground, is that this is all you're getting, is you're getting put in category as some sort of half-wit who's talking out of his ass, and he has no math, and he has no this, and he has no that, and he has nothing. And you're just like, well, what am I supposed to carry in this suitcase except an argument? All I can do is make an argument.
Yeah.
And I thought that, to me, it's a very persuasive argument. The argument where I explain how, well, inertia has never been explained by science or physics. I've explained it.
Yeah.
So doesn't that account for something? I can explain what velocity is and why it, creates time dilation.
Those people, they have no concept of where what the arguments hinge on. Like, they don't understand the overall structure of where physics is at, where, what the questions are, what the weak point. They have no clue. They hear something, each thing is just an asteroid for them going by. Like, they can't put any of it together. So there's really, I realized I was just like, this is just absolutely pointless to talk to these people. They just have no fucking clue. And Piro has got like multiple personalities about physics. You never know what he's gonna say.
Well, he's impossible, just because he concedes so many arguments and then he just retracts his concession, and so it's impossible to have a reasoned conversation with him, because he just keeps. You have to talk about moving goalposts. I mean, every conversation, and it always comes back to just keep reciting the same shit. I mean, he keeps going on about that stupid land tax crap.
Yeah.
And it's like, fuck you. You're just an idiot. I mean, he's just, I got to throw him in the idiot category, because he's impervious to a rational argument.
Mm-hmm. Yeah. Or sometimes he'll kind of take this position where he's like, well, I don't really agree or disagree. I'm just trying to, figure out where you're at, and then I'm going to juxtapose that to where someone, like, he'll just do these, like, he won't take, if you get him pinned down, and then he'll just claim that he's not interested in his position.
I'm not really talking about reality, or I'm just, it just turns into an abstraction like Hoffa Day or something.
Yeah, or he's just some kind of spokesman for whoever you disagree with at the time. Like, he's a devil's advocate, I guess, is the care. But it's obnoxious, because he's like, he won't let you actually get to any ground. He won't actually help the conversation gain any ground, right?
Yeah, well, he's one of these assholes who doesn't think there's a truth to be described, and so fuck you. We can't agree that we're trying to describe reality, and there's one reality, not contradicting realities, then there's no point in having a conversation, because I'm not having a conversation for any other reason.
Yeah, he
There's
gets
no
into
other
the whole,
point. I mean, it's just absolutely no point if you know.
yeah, he gets into the whole wishy-washy, brain in a jar mixed with Hinduism kind of nebulous territory of, you know, how do we know we're not in the Matrix kind of arguments.
Yeah, he always has a window to jump out of.
Yeah,
You know,
yeah, it's pretty, but you know, that's very common among people who fancy themselves intellectuals these days.
Yeah, no, it's really pitiful. Yeah, I mean, it makes it a very difficult environment, because you can't really get any traction, you know, because all you're doing is defending yourself against people who say you don't have a right to have an opinion.
Yeah.
It's just like, man, I know I have a right to have an opinion. I have a right to make an argument, and you have an obligation to make a counter argument, not to just slander me.
Right.
Yeah.
And then there's this amnesia where it's like you win the one little argument and then, yeah, they forget. And you have the next argument and then they go back to the first argument.
Yeah, I mean, Hathaway actually thinks it's an established fact that reality is an abstraction. So he actually thinks that, you know, he's in a position of authority with this argument that Einstein meant that we're supposed to believe that, you know, and it's, we're talking about Einstein of all people, right? So he's basically saying that Einstein thought that reality was an abstraction, when Einstein argued exactly the opposite against Bohr, right? I mean, Einstein was in total opposition with this nonsense that reality couldn't be described.
Yeah.
I mean, it was entirely his position that, yes, it is describable. It's never in some sort of superposition. It's never in a Heisenberg uncertainty. It's never in any of that shit. It's a cause and effect mechanical universe. And that's what Einstein believed. He didn't believe it was any fucking mathematical abstraction. So here he is arguing with me that Einstein's equation is not to be thought of as a representation of material reality, when in fact that's what it's supposed to be. It's supposed to be a model of the function. It's not supposed to be an explanation of the mechanism. The bent space was the mechanism, and the bent space was silly.
Right. And the math doesn't imply bent space anyways. There's no equal sign that says...
Well, I'm just saying, there's no bent space variable in the math. So there's no tie between the two.
No, that's
it. One is a description of the effect, and one of them is a description of the cause.
Right. Well, the bent space thing too, it's just an interpretation in the end, because it's like, basically it comes down to the fact that
I could replace the variables with exactly the ones I just pointed out for a light bulb. I mean, it's exactly the same formula. If you want to figure out how a light bulb affects a light bulb, and just make the photons inverted energy. So all the reflected light, all the light that bounces off the photon, just think of that as light that pulls the light bulb towards the other bulb, right? And as soon as you do that, you have exactly Einstein's field equations.
Yeah.
So Einstein's field equations are exactly describing two light bulbs where the light they emit is attractive.
Right. Well, the other thing it's sort of that it kind of is interesting about it, like, or what I think that what it actually does describe is it describes relativity, but then it mistakes the relativity as being the fundamental condition, where it's actually just a description of the
Well, I know, but the
theory of the observer.
Relativity doesn't have any meaning in the gravitational equations, because that's only the velocity element, and the velocity element's because the velocity is increasing in multi-dimensions. And if you recognize that that can't happen, that what really happens is all objects are like gyroscopes, and they just combine whatever velocities they have into one velocity.
Yeah.
You've gotten rid of that problem.
Yeah, I agree with you. What I was trying to say was that it's a theory of the observer, right? It's saying, like, you know, if we're on this side of the galaxy, we're seeing the other side 100,000 years ago. And if we're in the middle, then we're seeing both sides from 50,000 years ago. And it creates a dynamical system that describes what you'll see in terms of time. But it's not but you know,
but
that's
it has nothing to
interesting,
do
but
with,
it's
there's
not.
no seeing. There's no seeing. That has to, there's no such thing as an observer ever. So that's the bullshit. There's no real clock.
Well, I'm not trying to argue.
All the clocks are broken, so you can't measure time except when you establish what your origin for the time is. You can't have like if I draw a graph paper, the graph paper is a standard, okay? And as long as I don't bend that graph paper for each object having its own because of its velocity, that's breaking the rules, right? So I'm just saying, as long as you establish what you're going to use to measure time, and it's not dependent on either object being the timekeeper.
Right.
You know what I mean? Like if I'm in a race, I can't say I'm gonna time the race. Okay, that's sort of like, obviously that sort of breaks the game. I'm just saying you can't have the clock in any of the players' pocket.
Mm-hmm.
The referee can't be one of the participants, however you want to put it. But I mean, I'm just saying, there's no way you can't measure time from perspective.
Yeah, I agree. I'm not trying to defend that point. I'm just saying, like, it has some sort of interest as a curiosity in some regard, but it's not a theory of the. It's not a.
Yeah, well, I'm just saying the only thing that Einstein is putting together when he puts space-time together, he's just recognizing that velocity changes the individual metabolism.
Right, the cycling.
So there's a relationship between your velocity and your mechanical function.
Yeah.
But that has nothing to do with whether you're going to fall into a gravity well or not.
Right.
The absolute is going to take care of that. Your absolute speed is going to dictate that.
Yeah. Yeah, and it's interesting that his descriptions of it always include, actually having a physical clock present. And like, that's the element that they use to make these determinations. So it would fit with your model as well, with the time dilation, because it really does require that you actually have the metabolizing structure as the measurement.
Well, I'm just saying that what's obviously not being appreciated is that there's velocities that you can't see.
Yeah.
Okay, because there's accelerations you can't see. So you don't see the Earth accelerating towards the sun. You just see the Earth moving in an orbit around the sun.
Yeah.
Right? And you don't see our acceleration towards the Earth, even though because we don't gain any velocity from it. Right? So we don't go faster and faster and faster because we're stopped by the Earth. But the fact is, we are being accelerated every second 9 meters. Okay, so every second we're moving 9 meters in terms of actual force pushing through us, but we're getting the rebound, right? The fish coming back at us.
Yeah.
So we're getting accelerated up and down. We're getting bounced. And it's that bouncing that they're not, Einstein's accounting for it, but he's not describing it, right?
Right.
So he's using bent space to describe the bounce.
Yeah.
He's distorting the grid work to describe the bounce. And what I'm saying, no, keep the grid work alone, leave the grid work alone, and just draw it as a bounce. Okay.
Right.
And you'll have the longer line. So
well,
Einstein's making the longer line by bending the grid. And I'm saying, no, don't bend the grid, put the bounce in.
Right. Well, another way of looking at this as well is that the kind of fundamental weakness of the acknowledged fundamental weakness, which is why they say that, physics isn't unified in the sense that quantum physics isn't unified with relativity, is that general relativity is a dynamical description and not a mechanical description. Right. So, and then they're trying to apply the dynamical type of model to the mechanical. And then that's how you end up with the curved thing. But it's just,
well, they're all dynamic systems, though. That's the problem. It's all, that's sort of my argument, is that gravity even itself is inductive.
Well, yeah, but I'm saying that
it doesn't exist until you induce it.
Yeah, but it's a thing where, in general relativity, there is no particle. They don't define any unit of, it doesn't require that. It's a description that's based on
I know, but still, right, I know, but my argument would be is that all I'm saying is that you don't have to, there's still a thing with a velocity, and my point is they're denying the existence of the invisible acceleration and bending the space to account for it.
Right, because they're just...
So the acceleration you can't see, they're bending space to make relevant.
Because they don't, well, there's no...
All I'm saying is that if you were to do it, it's like me describing why light takes time to get through a piece of glass, right? I could say it's not traveling a straight line. Okay, that's the simple answer, right?
Yeah.
The light takes longer because it's not traveling a straight line.
Yeah.
So that's the simple answer, right? But now they'll sit there and dilate the glass or something, or come up with some sort of bending of or warping of the dimensions of space-time, when
Right.
no, all that's really happening is the glass is ricocheting through, and the light is ricocheting through the glass. Essentially, it's being
Right.
captured and
So
released.
that's what I'm saying. They're
And that's
dodging.
what has slowed it down. So it's taking a much longer path to get through the glass than the straight line. And so, but it's a real path. It's not an abstraction. It actually travels more distance.
Right.
I
So
travel more distance on the surface of the fucking Earth than a satellite in space.
yeah.
Travel more distance because I'm bouncing faster. Okay. Okay, I'm in a stronger gravity and it's bouncing me faster. Okay,
Yeah.
it's like a basketball. You know, you put your big bounce slow, little bounce really fast. There's more distance in the little bounces.
Yeah, well, that's exactly what I'm saying. I'm saying that you're explaining it in a mechanical sense. Like when you're saying it goes through the glass, it goes along different paths, and that's why that's a mechanical explanation. And in general relativity, they don't have one, so they just skip over it basically, and that's how you get the bent space thing. They don't have mechanical explanation, so you just assume there isn't one.
Well, I'm just saying it's not even that they don't have mechanical. I don't mean to be anal about this, but the real argument is because it's not visible, right? The acceleration's not visible.
Right.
So that's why they have to account for it, because they know it exists. I mean, in a sense, they know it takes time, right? It's taking more time, so obviously there must be something more happening. And so they're accounting for it in the sense they know the side effects exist. But the point is that they're misdescribing it because they're not understanding that it's actually acceleration that does exist.
Yeah.
Even though I'm not moving, I'm accelerating.
Well, that's what's meant by unified physics.
Yeah.
That's
Well,
why
I just mean that it's the difference between that particle thing and the whatever the alternative is. But yes, it's real physics, real physical physics versus physics dependent on abstraction.
Right. Well, but they acknowledge that their physics is not unified, right? So that's the unification problem that they have. And
that's even a bigger problem, the fact that they haven't come up with axioms that are applicable to the real physical universe. So they have axioms, they have principles, right, that aren't consistent. They can't be used in all of the universe, where obviously I'm arguing the empty space between galaxies is the same empty space that's between electrons and protons, and the same empty space that's between an atom and another atom. Empty space is empty space. It's all the same empty space. And quite obviously, you can't talk about, space contracting and expanding unless you're going to explain how it did that inside of an atom.
Yeah. Yeah, or if you have to explain what it is, which.
Well, I'm just saying that the idea that the space is something is their first mistake.
Yeah.
It's not the first, but it's obviously a colossal mistake, was to allow the dimensionalization of a non-existent thing.
Where they're creating this insoluble problem for themselves in their premise. Yeah.
Yeah, and their very premise that there's something other than 3 physical dimensions. That's just a huge mistake. There's 3 dimensions. There's no other dimensions. Everything else is a function in the 3 dimensions. There's nothing else.
Yeah, well, that's one of those major, it's the fact that they can conceive of adding dimensions in math. So then that's the only reason to ever even possibly consider that there was any more dimensions.
Well, right, and it just makes it so convenient because, right, you have a mathematical consistency problem. That is, you have axioms that aren't consistent. So what do? You create a comic book where the rules are different.
Yeah.
So you tell part of the story is my real life, like I go to school and I do this and I do that, and then because these other axioms don't fit, I'll just write the comic book part over here. And that can have separate rules. So in the comic book, I ran off the edge of the cliff and then realized I was hanging over a cliff and I ran back again. I can do all kinds of cheats in the fake universe, in the fake comic book world, that couldn't possibly happen in this real life world. And that's what so it just gives them an ability to have false axioms, which are, I survived, the great battle of Atatok, and they just make up where Atatok was in Atlantis or something, and they just make up a Cleopatra life for themselves.
Yeah.
And Napoleon, I was Napoleon.
Yeah. Vainglory.
But yeah, it's not physics. I mean, this is just, like I said, this is just so. I mean, I guess this is always a problem for me, because I always thought of physics as being physical.
Yeah.
So I was always attempting to imagine everything I saw as a physical thing, and understanding it as a physical thing. And they just kept, they kept trying to do this wave crap, and you're just like, how can you make a wave that just sits in a little spot, just waves over here? Just on a wave, and I'm not waving anywhere. I'm just waving this way.
It's weird, human beings have this amazing capacity to be. It's like, take Isaac Newton, for example. The guy was a complete kook.
Yeah, that is the funny part, is that you have to be a little bit.
He was way in the deep end. He's way off the deep end. The guy's a complete nut, just the worst nut you've never even met a nut like this nutty. But he also figured out the laws of motion and created,
Well, I'm just saying he was neurotic. I don't know if I call him a nut, but yeah.
Well, he spent most of his life studying the angels. After he did all his real work, he retired to studying medieval sorcery, basically.
Yeah, well,
I just got through reading a little bio.
Yeah. I mean, that it is kind of embarrassing.
Well, no, he was a real nut. So I'm just saying, it's like, that's what don't underestimate a little bit of that vestigial nuttery left in people who are otherwise intelligent. Like, some parts of their brain are working good, but then they're also a nut. How does it happen?
Well, that is a little bit, like I said, that's almost inexplicable, because you almost say that, you have to have high reasoning and logic skills, to be able to do the deductive work, to do what he did, and then to think that he could waste neurons, on angels.
He was a biblical literalist. He predicted that the world would end in 2035 based on a mathematical analysis of the Old Testament. And he's a real nut, real nut.
Yeah, it is.
No denying it. I mean, I hate to say it. I was.
Well, I know he was a bit neurotic, but I was kind of forgetting about the whole Christian thing. He really was, he was
he's seldom heard of even people in that time being that Christian, being that completely bizarrely Christian.
Yeah, because you can't, the one I couldn't get over was the fact that, he lived a mile from the ocean and he never saw the ocean. I mean, he looked at the tides and he never went and actually saw a tide. I mean, that's just amazing.
Yeah. Well, that sounds like it almost might be a bit of, it's hard to prove that he never actually did, right? Or maybe he, that's part of it.
He might have said it somewhere, He might have admitted never seeing the ocean or something.
Yeah, but he was batshit crazy, so it's hard to take what he says seriously, right?
Yeah, well, and then you got all these people that are, well, I don't even get into that stuff, but you have accusations of who stole what from who,
Yeah. Well, yeah, and he was also privy to, at that time when they were first unearthing the texts of the ancient Romans and Greeks, he was part of the kind of societies that had access to that material. That
well, I'm just saying, it's not like he did it from scratch, so that's for sure. But
yeah, and that the people in the ancient world were surprisingly.
Well, everybody's more of a fraud than you really want to even pay attention to. But it's like, I always got irritated about Darwin. When I found out his grandfather believed in evolution, and it's like, well, why does Darwin pretend like this was a hard sell for him, that he actually had to, work at it to be convinced when, his grandfather was convinced?
Yeah.
And
Well, somebody told me
he didn't have any of the evidence Darwin, accumulated. And he
apparently.
had already believed it just by watching people breeding animals, and it just seemed obvious to him that over time, animals would diverge from their form by selective breeding.
Well, yeah, and then when you mention that, it makes me think that people who are experts in agricultural techniques, because that's what people did, they at least had a kind of microcosmic version of that understanding already in place in order just to do the selecting themselves. And
well, I'm just saying we already hibernized, sheep, cows, and wheat. The big one. And so we'd already made vegetables. We've already been alchemists in a sense, with evolution. So I mean, like I said, it wasn't much of a leap to say, well, given enough time, this selection thing could really go somewhere. I mean, you could really break how stuff looks. And you just see it in the sense that, people from different locations of the world had features that were unique to them, right? There were black-skinned people, brown-skinned people, the people with big noses, small noses. They already knew all that shit.
Yeah.
Well, it just seems so obvious that, it seems regional because that pool of people is only breeding with that pool of people. And if I mix it, they probably already knew that if a white man, a black woman have sex, that they're going to have babies that might be all kinds of colors.
That's the first thing they find out.
Yeah, I mean, it just seems so obvious. Well, why wouldn't you say that, it seems to have something to do with where you're from? Yeah. Somehow, like, your fromness is part of your physical appearance, and somehow that is incorporated in the egg. Duh. Yeah, and, all the other animals, like if I breed 2 pigs, I don't get a sheep. Yeah. So, gee, I'm just saying, so when you think about the context, you're saying, why did Darwin even have to make this argument? This should have been something people already knew.
Well, I think you could even pretty easily deduce that it was adaptive, because it's like I spent some time in a place that was right on the equator, and I have about the same complexion that you do. So it's glaringly obvious to you that you're not evolved for that place. Like, you'll get a deadly sunburn in 5 minutes if you don't have a Lotus sunscreen on. And it's like, but all these other people, they're fine. And the dark-skinned people, and it's like, oh yeah, you're gonna make that connection pretty quick. Well, my skin gets darker when I'm in the sun, and that confers protection, right?
It's clearly a mechanism, Yeah.
And then you're fucked. When if this was 500 years ago, I wouldn't be able to work. I would just perish. I wouldn't mate. I wouldn't pass on my genes, and just in that primitive scenario, because I'm like, these men who have dark skin are all gonna outwork me by a fucking 100 times.
Yeah, and I mean, there was so much of that was just so obvious. And like I said, we had already explored a lot of the world and ran into these different cultures and found that people in cold climates were shorter. I mean, all kinds of, they were stockier. This whole thing, it just makes rational sense that they would be able to, maintain their body temperature that way. And I mean, just rational deduction gets you to this conclusion. I'm not saying what Darwin wasn't valuable. I mean, but I just mean that I was sort of irritated that he made it seem like this was some kind of new innovative thing that was falling on him, this realization. And I was like, what the fuck are you talking about? I mean, this is your grandfather's story.
Right.
Well, I think your story, and he doesn't even mention the grandfather in the book, which really irritates me too, because it's like, that should be a context for this conversation. The fact that you, as a kid, were having conversations with your grandfather about the origins of the species. I mean, fuck.
Well, this is this problem with having these cults of personality surrounding certain scientists, right?
Yeah, it's Darwin's theory, instead of it just being the argument for evolution. It's all somehow tied to Darwin, and Darwin, although a player, he wasn't even a very good representative of the argument. You know what I'm saying? He was so milquetoast about everything, and so I mean, he was so
he's a rich man.
Underestimating the import of this conclusion and its implications. He was just too, lazy, and well, lazy is the wrong word.
He was fucking rich. He came from it was like the equivalent of like the people who own the
I know, but that's a side issue in a sense, because obviously you had to be rich to have the leisure time to do any science.
Well, and at least he didn't put it into leisure. No, but I'm just saying that I'm sure that informed a lot of his douchebaggery. Just not his fault entirely. I mean, didn't choose to be born rich, but especially in those days where you just had like the ideal was to be a gentleman, so that meant that you're a man of leisure, that you ride
Well, I
horses,
just mean that he had
go
done
on
it.
a fox
You
hunt.
know, it's
whatever.
almost like before he went on the Beagle, he already had this stuff because he'd already been doing experiments with, you know, he did a lot of biological research, and he lived near the ocean, and he did a lot of stuff with, I can't remember what it was, like barnacles, maybe.
He was trained as a geologist.
Yeah, he did a ton of work with barnacles.
He got his degree in geology. Not, interestingly, he was, and his first book the book that he was commissioned to write for his Beagle voyage was a geological survey, not a biological survey. And he just happened to collect the biological, or he was doing it for a colleague or something. And then it turned into he found it more interesting as he went along, that his colleagues, like what he started to see, the pattern that emerged, because he was very good, at least he was very thorough.
Well, I mean, the geology was an important part. The fact that he knew some of that too, because that really came out with the Galapagos thing. Because I thought one of the most, one of the best arguments for evolution was the whole he gave a very rational description of the continental plates moving.
Yeah.
And the idea that the islands were in fact moving away from their source of origin. I thought that was really smart that somebody could figure that out. And they could tell that this side, the islands farthest away had the most diverse life on them, and the islands closest to the source were the least populated and the least diverse. And to me that was a really, because it gave the time scale, because now you could start imagining 1,000,000 years or 100 million years or 300 million years, and it all started to make a hell of a lot more sense.
I think he was a good scientist. I mean, apart from whether, I don't know too much about the whole.
Yeah, I think he was a great scientist. I just mean that he's a poor poster child for evolution.
Well, they don't need a poster child.
He was so lame and tame on its implications. Its implications are huge.
We shouldn't have a poster child for a theory that's that everything, for us, like everything is always linked back to evolution, and when you're trying to study
well, it is unfortunate that once you have recorded history, then you always record everything, and so you're stuck with that record of its origin, and somebody's always got to name it, and that's always the unfortunate. Some asshole came up with whatever happy quark, and
well, evolution is it's often referred to without Darwin, and I think that give it another couple hundred years. I just
mean that if the wheel was invented, in the 15th century or something, I'm sure it wouldn't be called the wheel.
Right.
It would be called the Joe Freddy.
Yeah. Yeah. Well, I guess some things do is that, like, we just call it airplanes, and not everybody knows that the Wright brothers invented it. And some things are just, it depends on how commonly they're used, I guess. But like, I mean, I don't usually call it Darwin's theory. I usually call it evolution.
I understand, but I just mean that Darwin is it's tied to it, is all I'm saying.
Yeah, he's tied to it.
Darwinism,
Well, and then it has all these weird, unnecessary political tentacles, and when you bring it up, people just assume you're talking about social Darwinism, but it's also.
I just mean that's why I just found Darwin to be a little bit irritating, and that he kept leaving some door open.
Yeah.
Or like, oh, well, this isn't totally destructive to religious theory. I mean, of course it is.
No, I think he thought it was, didn't he? I mean,
well, I mean, he didn't though. He didn't at all aggressive. Like, he ends the book with kind of a famous line, like, basically just saying something that the creator from one source of created something, implying that the original source material could have been inspired by a god, that kind
of thing. The way I understand it is that he was actually
he didn't touch
personally an atheist.
He didn't touch the abiogenesis element of it. He didn't take it the step a geologist or a chemist would go,
Yeah.
Where you would just conclude that the biological function was itself a byproduct of the mechanical function of the universe.
In a biography that I read, it sort of said that he was privately very much an atheist. He lost his faith early in life, but that he was preserving his wife's emotional well-being.
I'm just saying that that's what I'm saying though.
Yeah.
That's why he's a lousy poster child, because
right.
he had this sympathy for the ignorant condition, which I just find so obnoxious.
But when is a poster child ever not lousy, right? It's just, we got to just quit that. Quit having the fucking poster children because they suck.
Well, I suppose.
They just lead to distortion.
I think I would make a very good poster child for anything. So.
Well, then maybe it's, you can turn a bad into a good, but I can't see it's been that it's ever been much good. I think it's done a lot more harm than good.
Well, I just mean, I think evolution would have been a better fight if Darwin was better at fighting the fight. That's all I'm saying. Yeah,
I think he was really kind of a meek soul. From what I gather in this bio that I read. I mean, that's not the final word on the subject, but it seems that he was a quiet and introspective kind of dude, and he actually.
Oh, yeah, well, he was he was terribly ill,
Yeah, because he was kind of a frail and meek kind of man.
10 million parasites he picked up on his voyage, so.
Yeah, well, he married his cousin. He was not very, which is a sort of a sign that someone doesn't get out much, right?
I suppose.
Well, I mean, could be seen
it kind of depends on how hot the cousin is, I guess.
She wasn't good. Yeah, she wasn't hot. I think they married to keep the money in the family. It was a tradition.
Yeah, well, that's pretty weird then. Yeah.
Well, that was it's hard to imagine the Victorian era, but it was much more almost like kind of partially arranged marriages, right? Like you were limited to.
Well, I just think
society people.
I just think
if there wasn't many people richer than you, then you're gonna end up fucking inbreeding.
Well, I just mean that you think you kind of even know that inbreeding thing is maybe not a good idea.
Yeah, well, Darwin turned out okay. I mean, his parents were cousins too. They're a massively inbred family.
Well, I'm just saying, it wasn't that good. His health was kind of marginal.
Yeah, well, his health, but I mean, it didn't. You'd think retarded is generally the stereotype. Well, you're right though. Actually, never mind.
Yeah, no, I think it can affect lots of organs, not just your brain.
Yeah, maybe it did good things for his brain, but fuck the rest of them. Yeah. He had no balls. He had small little raisin balls.
Well, he did have pretty big balls, actually. I mean, shit, you wouldn't get me on that crappy little boat.
Well, I think he was just naive, actually.
Well, I suppose, yeah. I mean, he was seasick the whole trip.
They didn't have National Geographic back then, so he didn't know, didn't know what he's getting into.
Yeah,
that's the only thing he ever did.
You just look at the ocean and just say, I'm getting in that little shitty boat, and we're going to go out there in that thing,
That's all the adventures he ever had. He went out for the 3 years. He came back. He never left his house again.
I know. Well, that's because he was totally debilitated.
Yeah. Well, yeah, some of those tropical bugs, though, I almost died once from a tropical illness. And
well, I mean, it's before antibiotics and all that shit.
Yeah.
So once you were infected with this shit, you'd end up with a worm for the rest of your life.
Yeah, some 30-centimeter long.
He was going to the hot springs all the time, getting the water, going to the going to the whatever, the mineral springs or whatever,
putting leeches all over him and shit,
trying to get
mercury.
Yeah, so he was constantly trying to get cured of his ailments.
They used to give people mercury who were mentally ill.
Yeah, well, I used to play with it as a kid. I liked it.
Yeah. Well, I think if you don't eat it, it's.
Yeah, I'm just, everybody has a lot of stuff about stuff. I don't know how much it's, obviously, I don't think you could drink a glass of it and it's not going to do much good, but,
Well, that's what they would give the people back in the day. But maybe, maybe there was just a way of killing them without saying so. Who knows? I mean, it seems like they should have figured that out pretty fast, but.
Yeah, well, it's the heavy metal poisoning is a little tricky, you know what I mean? It takes a long time to actually store it up in your body, so mercury would just go through you, so they probably thought it was a tonic.
Yeah, I guess the real danger is when you inhale it, because it turns into vapors and stuff.
Yeah, well, the gas is a little more dangerous, yeah, so, but I still don't know exactly how fatal it is unless you got to have a really special circumstance where it actually kills you.
Yeah, I have no idea. I mean, I guess they sort of exaggerate for effect. I mean, I've always assumed that it was very dangerous to inhale any mercury, but I don't really know exactly what the threshold would be.
Yeah, it's just that heavy metal thing. You know, it ends up getting stored in your cells, and so it fucks up the function of your cells over time. But you can do that with too much iron or too much anything. So
yeah. Well, I guess you can pass iron through the cell wall where you can't pass mercury or something like that, right?
Well, I'm just saying that the arsenic, all the heavy metals are tend to want to stay where you put them because they're heavy. You know what I mean? They're sticky. You know,
yeah, I was watching some mercury experiments just for fun, and it was amazing to see this guy that, you know, you could take an iron ball, throw it into mercury, and it floats like a cork, like right on the top of the water, right on the top of the surface of it. And then the guy actually put his hand. This guy's like, I've always wanted to do this. He filled up like a 2-liter pop bottle half full, and he put his hand in, and then he pulls his hand out, and there's so much pressure it pushed all the blood out of his hand. So his hand went numb.
Well, I mean, I didn't play with that much mercury, but I did. You know, my father was a chemist, and he actually had some in the house, so I played with it a lot. You know, and you know, it was just fascinating. You know, you know, because it is like there's nothing like it. You know what I mean? It's just so different than anything you're used to.
Well, this guy had, like, he said it was 25 pounds of mercury, and it was like a liter.
Yeah.
Stuff is heavy.
Yeah.
And it's it's very mysterious stuff. You can really see how in the ancient times they must have really thought that was something.
Yeah, I mean, it just has magic written all over it in a way. You know, it's just so you know, like it's alive.
And it mirrored surface.
It does the Pyrrho-scene thing. You know, it seems like something because it's so different. You know?
Yeah, it's like the Terminator liquid metal guy. You think it's going to turn into a humanoid and stab you?
That was kind of sucky, actually. I really hated that. I mean, I love that. It was a great movie, but it was just that was like a little over the top for me.
Yeah.
You know, oh, it can make stabbing things, but it can't make shooty things. Can't make a catapult. I'm like, oh, why can't I make a catapult?
Yeah.
It seemed kind of lame.
Yeah, or why would it bother shooting guns? Why wouldn't it just?
Yeah, right. It can duplicate a human being, and you're just saying what? It can't make mechanical devices, but it can duplicate a human being. Oh, okay, that makes sense.
Yeah, or why wouldn't it just hide? Like, disguise itself as the environment, wait for people to come, and then just envelop them and wrap around them and kill and crush them.
It sort of did that to the one guy at the hospital or whatever. It pretended to be the floor.
Yeah, but you'd think that would be its main go-to. Why would it stay in this man form when it could be the environment?
Well, it has to get information, so it stays in the man form just so it can integrate with the system and get information.
Yeah, no, but then it goes after them and tries to kill them in that form when it should really just turn into the environment and be invisible and then just wrap around their faces.
Well, you would think it would just turn into something that moves faster than a human being. So,
yeah.
Why not just morph into a cheetah, you know, so you can run faster?
That would be cool to see that animated, like it just transforming into like creatures of convenience, like it turned into a bird and then a cheetah and then it's an elephant just stomping on him and then he's shooting a pump action sawed-off shotgun at it.
I would just blow my brains out. I just say, "Fuck this!
Yeah.
Too silly. This movie's too silly. I'm gonna have to kill myself."
And why wouldn't he just open a hole to let bullets pass through? Why did it get slowed down? You shoot the thing with a handgun enough times, and it's like, that doesn't make any sense.
Yeah. Well, that part was another good point. But yeah, exactly. Why would it just say, "I'm not accepting bullets today"? Yes.
Why wouldn't the bullet just pass through easily? Why would it actually disable it for any amount of time? That doesn't make sense.
Well, I'm just saying, why doesn't it just make itself into a SpongeBob and I'm a sponge.
And then you find out it's easy to kill them.
You can't shoot a sponge.
All you need is a couple super soakers full of liquid nitrogen, and then some liquid iron, some molten metal, and then that's all you need. So why didn't the Terminator already know that, or he must have known something about it? Wouldn't he have just gone right for that? Just you need liquid nitrogen to kill the fucking Terminator.
Well, you can't kill him with the liquid nitrogen.
No, but you need that to start to kill him, right? That's a good way to kill him. You freeze him.
He was already phasing him little by little. After the first explosion, he was already, a little bit lame. You know what I mean? He'd already started dysfunction a little bit.
Well, you could break up all the pieces and store them separately. That might be a partly effective way of.
Yeah, well, that was another, it's another element. You're just saying, like, when it was all falling apart after he shot him, then he should have just he should have just kept kicking all the pieces away from each other, just so he can't turn back into one thing again.
Yeah.
Put all the pieces in lock boxes.
Yeah. Dump them into different volcanoes.
Yeah, just stick them in different piles and, shove the piles in different vats or something.
Yeah.
But yeah, I mean, there's a lot of should have, would have, could have. Yeah, it was a good movie overall, though.
Yeah, or they could have done cool stuff they didn't do, though. Like he could have been put part of himself as someone's drink, and then they could have drank him, and then he could have burst out, and they could have.
Yeah, I suppose. I really, like I said, I really didn't care for the, I just, it's too over the top of character. So yeah, I didn't want him doing anything else sillier because he'd already done enough silly shit.
Yeah.
So it was already too silly for me. But yeah, I mean, there was a lot of good stuff in there in terms of the.
I haven't seen it in decades, I think, at this point.
Yeah, I guess my favorite bit was where he crashes the truck. The nitrogen truck, and he rides on top of it. I thought that was pretty good.
Yeah.
Yeah.
Or when the part where he's not supposed to kill any of the police, so then he just.
Oh, I hated that. I hated that because that was just that was too lame. Yeah, they're not fuck that shit. You're fighting for the whole Holocaust of all of mankind, and you're going to start worrying about cops. Fuck that shit.
Yeah.
And I wouldn't bother. He's that stupid scene where he's walking towards the cops and they're shooting holes in his face and everything, and you're just like, well, why would he get himself all fucked up for nothing? Why doesn't he just terminate them?
Yeah.
Why doesn't he shoot them from 100 feet away? He's probably a good enough shot to hit him in the knee.
Yeah.
So, yeah, that was stupid. But yeah, I mean, once he had the minigun in his hand, I just wanted him to, fuck them all. Fuck them. Blow their faces off.
Yeah. I don't remember it with that much detail, but.
Yeah, well, I know.
I agree with what you're saying, basically.
Yeah, I mean, he's a Terminator. You know what I mean? I want him to be a pussy.
Yeah. He's the Determinator.
Yeah, okay, I won't hurt anybody. Okay.
Yeah. And then at the end, he gives the thumbs up when he's.
Well, that was good, but you had to feel better. You had to feel good about him getting killed. So, that was good.
He starts using the slang. He's almost human.
Yeah, he's doing okay. I need a vacation. I think I need a vacation. My arm fell off.
Didn't they just make a 4 or something? Did they make a Terminator 4? Am I just imagining that?
Well, they did. Yeah, they must have, because they made a 3, so there has to be a 4. 3 was the chick one, right? And then the 4 was the I don't know, something all went wrong again, backward thing or something.
I haven't been following it.
Yeah, so I didn't see. I got the 3. I couldn't even. I started watching and I was like, oh man, this sucks. Yeah, this is really bad Terminator.
Yeah, being all this YouTubing has really displaced TV and movies from my life almost completely. Because now it's like, there's physics videos, and I'm just like, well, why wouldn't I watch something I'm gonna learn something from?
Yeah, well, I have to admit it. Just making the Mendham videos, the philosophy ones, and doing the science shit, doing it. Yeah, I don't have any. I haven't. I have movies running on my digital things. So I just see them now and then. You know what I mean? I see a scene from a movie. Like I have Terminator on the one over there, and
right now you're watching Terminator.
I have 12 Angry Men on the other one.
Oh yeah, that's the film you watched hundreds of times.
It's Terminator. There's 6 movies that run on there, but it's actually running right now. Yeah, so let's see if I can move this camera. Now I can't move it. But there's one. There's a. It's right. It's right over. Where is it? It's it's behind me. I mean,
it's all right. I believe you.
It's right over there. Let's see. Oh, no, the chair's in the way now. How the fuck is that in the way? That's irritating. further over that one. See, but there's the laptop. It's right below the laptop, actually. It should be right there. It's in the way. Huh. You can sort of see it right there. See it right there?
Yeah.
No, that can't be it. That's too high.
I see blue on the screen, though.
Yeah, that's not. Well, anyway, it's right at the scene where they're going into now the helicopter. You know, the helicopter's going around the building.
Yeah.
So it's like the Terminator's going to jump into the helicopter any minute now. Yeah. So that's the part it's on. So, but yeah, I have like Leon, the Professional, on there, and a couple other movies.
Yeah.
So anyway, so I just see bits and pieces. But yeah, that's all I don't watch any other entertainment.
Yeah, where do people find the time? I don't know.
Yeah, so I'm just too busy, and I always feel guilty if I don't watch a physics lecture or physics related video when I eat. So it's like every meal is with physics.
Well, once you get into these things, it's just there's not enough hours in the day. Like, yeah. I've got a backlog of videos, and including physics and some other more serious topics that I can't keep up with my feed, really. Yeah. So I don't know. I can't really justify watching Seinfeld or something.
Yeah, there's really just no time for any fun.
Yeah. Well, I find it more fun to watch that shit anyways at this point. Once you're in, once your brain is in it, it's more rewarding than watching people make stupid jokes.
Yeah, I suppose. I'd rather just win the philosophical argument, win the physics argument, and then I would just live a life where I could watch movies again. I like watching movies. I like suspending reality and just getting the fuck out of,
Yeah, maybe.
I hate this. I hate this job I have of being the defender of truth. I really find it irritating.
No, you don't seem like you hate it.
Yeah, I hate it.
It's a love-hate thing, maybe.
No, I don't like any of it. It's all.
It's just a duty. You just do it.
I'm just saying. I guess until somebody else does it, I'm stuck, right?
Yeah.
I mean, is there somebody doing it the way I would do it, or better than me? I mean, as soon as somebody does better philosophy videos, I'll watch them instead of me making them. As soon as somebody starts talking rationally about physics, then I'll quit and they can have it.
I was thinking about doing a channel, maybe I've been sort of playing with the idea. I was thinking about at least at first focusing more on. I've collected just a great collection of stuff to criticize and just sort of dissect. Make videos that, because I think that's unfortunately that's probably going to be the primary activity of making physics move, is beating it up before, because you have to soften it up before you can even get your shot in. For myself, I just look at it, it's all just science and ideas. So, but I think that there's a lot that needs to be destroyed at this point. It needs to be the wrecking ball.
All right, so anyway, these commenters are bitching that I'm not paying attention to them. For an electron to move, a photon must be emitted. Yeah, of course. Well, the human psychology needs fulfillment of intelligence and social experiments. Oh, who cares? Shut up. No input allowed, ? Fuck you. I don't even know what that means. I don't want to impose on the intellectual discussion in place, but I feel like you guys need more interaction and involvement in your audience. Well, what? Involvement with what? I understand you guys might be using this for documentation.
Join the room.
Gee, well, I mean, he's just being an idiot. Right.
Come on, join the room, buddy. Let's talk.
Well, okay, it says, would it be okay to ask to join the discussion as a third party? Well, that's where the link is in the description. It says room link. Yeah, you click on it and you're in the room. Yes. Gary, please answer questions.
Yeah.
Please answer what questions?
It's boring listening to people agreeing with each other.
Jeez. I mean, but a different guy asked, Gary, please answer questions. What question? There's no questions, idiot. No, he's the idiot who usually shows up. Anyway, I mean, I have been posting the discussion, whatever you people post in the chat, in the comments section after the video. I've been, in some ways, attempting to be responsive to you people, and you're bitching.
They should just come in the room. It doesn't, going this off into the written thing.
Well, don't bother coming in the room unless you have something to say, though, please.
Well, if they're asking questions on the chat, then come in the room and ask the questions. It would just be
they're not
better.
really asking a question. I mean,
well, sometimes they do, right?
Well, I'm just saying, in this circumstance, the questions are completely, I don't understand them. So, yeah, they're incomprehensible.
The question is, why aren't you answering any questions?
Yeah, it says empty space is always filled with pressure, right? Yes. Well, it's not empty space, obviously. The entire universe is made of quanta moving the speed of light. Some of the quanta has a frequency. We call that the electromagnetic spectrum. So from radio waves to cosmic rays, that's a form of pressure that's visible because of its frequency. And then there's another form of the pressure that's realized when it's polarized in one direction. Then we call it magnetism. And so, yes, but it's all the same shit. It's all quanta moving the speed of light, and some of it you can see, and some of it you can't. And some of it goes through matter, and some of it doesn't. So, but it's all fish. And the schools of fish are interesting, but they're made of fish. The fish are doing all the work. That's a good way to put it, I think. All the real forces and all the real rules only apply to the fish. They don't apply to the schools. Yeah, well, he says here, what do you think about gravitational waves? Well, I mean, obviously you haven't been watching any of my videos, but Einstein came up with a theory on gravitational waves when it was posed to him, question, back in like 1918 or something. I don't know, really a long time ago. It was in connection with the idea of radio waves, because they were realizing that radio waves, okay, were waves of essentially energy. Electricity would create this noise that would travel through the medium. And so the question was, well, does gravity create this wave? And Einstein was answering that question. And in that context, he understood gravitational waves to be in a scenario like a neutron star, where there's two objects spinning around each other. Would that frequency create a gravitational effect that we could hear, like a radio wave? So it had nothing to do with black holes. It had nothing to do with all the crap they've turned it into. It was just a question about whether this rotation creates a change in gravity, and whether that change in gravity would be something that could be detected at a distance. And Einstein's answer was, no, you can't detect it at a distance because it's too minor an effect, because of the inverse square law. So something that has to be awful close for you to be able to detect the difference between this and this. You would have to be right here to tell the difference between this and this.
And it's not a wave anyway.
It's not a wave, right? It's just a change in the shadow. Everything casts a shadow. Your shadow changes when you go from this to this. Okay, that's a shadow change. Your shadow is darker here than it is here.
It's a flick. It's a gravitational flicker.
Yeah, exactly. It's not a wave. It's a
oscillation.
Yes, it's a fluctuation in the intensity of the gravity produced by the gravitational field.
Yeah, it's an oscillation based on the frequency of the source.
Yeah, it's not, and you can't convert matter into gravity. So it's just silly. I mean, you can obviously nuke matter into gravity, but you can't do it in some way where it doesn't create a nuclear kind of effect. Obviously, you can't create mega gravity and then have it travel through the universe and not affect anything along its travels. I mean, there's speculation with these gravitational waves, 2 black holes collapse, 3 solar masses worth of energy is released, and somehow it doesn't affect anything else on its way. It doesn't push anything else out of the way, it doesn't move anything, doesn't do anything. These waves are unwritable by anything, but we can hear them. It just doesn't make any sense. We can hear them from 1 billion light years away. Just a crock of shit. How much do you agree with the electric universe, guys? Well, I argue with this all the time. Tesla was an idiot. Okay, I mean, he just was. Okay, he got one thing right, and that's the AC phased motor. Okay, so he took a motor that back in Edison's day, right? They made a motor that was basically a magnet here and a magnet here, right? They didn't do the circular thing yet. And Tesla, figured out that, hey, your motor's going to be a lot more effective if you're taking advantage of this magnetism all the time, not just on 2 cycles. So, it was a huge improvement on the function of electric motors. But beyond that, he was a crazy fuck who thought he could shoot mega electricity through the atmosphere. He spent the rest of his life trying to make synthetic lightning that would travel to Europe. I mean, he was an idiot.
I wanted to just say I thought of it because I heard what you were talking earlier about what the biggest star they claim how big it is. It's 1,420 solar radii.
1,420 of our sun's radiuses.
Yeah, called VY Canis Majoris.
VY Canis. Well, that's no good.
Oh, Canis, Canis.
Well, I'm not going to look it up. I'll just look up the 420 number.
No, 1420. 1420.
Yeah, so I'll have to think on that one.
Yeah, I'm just saying this is the reported that it's 1,400.
Well, I'm sure these relationships, I'm just saying, are probably going to duplicate themselves. So if you can figure out what the smallest sun is and what the biggest sun is, then you might be able to figure out that there's a duplicate pattern with the smallest galaxy and the biggest galaxy, and they might find duplicate patterns elsewhere that might have the same ratio built into them.
Yeah, and they're saying that this star is said to be only 3,900 light years from Earth.
Ah, so it's in the Milky Way.
Yeah, it's very close by, even for the Milky Way standards. Because the Milky Way is 100,000 light years across, and this is 3,900 light years away.
Yeah, so it must be, they're probably just reading it wrong.
Yeah, I think so.
We'll see what it is. I'll have to look into that one. But yeah, it's probably one of their big giant lensing splotches or something. I mean, I still can't believe they fall for that whole idea that the biggest galaxy they ever found is a lensed galaxy.
Yeah.
Just coincidentally, the biggest galaxy in the universe you can only see with a gravitational lens. Oh, yeah. Coincidence much.
Yeah, I can't even take any of that crap seriously at all.
Yeah, it's really bad. Bad.
They've really succeeded in brainwashing almost everybody into being vehement defenders of this crazy shit.
Yeah, and their drawings are just so bad too. Because the important thing in the lensing is just to not even think about it as a lens. To think about it just as this. You just need a piece of the lens. You know what I mean? It's like you're not really taking an image of something, so you don't need anything proportional on both sides. So all you need is one side of the lens to verify the lensing. And it's like this. It's so irritating because they just don't get that gravity works that way anyway. You know what I'm saying? That gravity has a field strength. Like say if you had the big universe and it was all even, okay, in terms of the mass, and you were on this side of the mass, you couldn't possibly make a round lens anyway.
Yeah.
You know what I mean? From that position, because you are so one-sided in terms of the gravity. So everything you do is getting bent towards the heavy side of the universe, so to speak.
Yeah.
You can't help but be influenced by the fact that you're in the minority mass of the universe. You know, you don't have it. You're not in equal pressure anymore. You're in unequal pressure.
And we don't have any fucking clue where we are in the universe.
Right. So you can't possibly have an even lens anywhere.
Yeah.
In the
Well,
universe.
we don't even.
So,
we have no clue.
I'm just saying, if you can't
be.
possibly make a gravity lens that would ever be an equal lens, so you could never have like the Einstein star or whatever they call that, the Einstein cross. That could never theoretically happen because that body couldn't possibly be in an even gravitational field.
Right. Well, it's like trying to use.
Like say if I'm in a galaxy, I'm gravitationally influenced by the other spiral arms in the galaxy. I'm gravitationally influenced by the center of the galaxy, and I'm gravitationally influenced by the galaxy's relationship to other galaxies.
Yeah.
So I can't possibly make a perfect lens. It would be impossible to make a perfect lens in one part of a galaxy.
It's like trying to use a piece of volcanic glass as a lens or something, like just some.
Well, I'm just saying the distortion would be always, your lens would always be bent to the biggest field. So it's like there's no such thing as a true neutral position. You know, in the universe, it really isn't. There's always a field somewhere, and there can be things blocking you from moving to the field. You know what I mean? Electrons can get in your way and that kind of stuff, but there's always leftover field in. Like if I take an electron, I just put it here in space somewhere, it's going to go somewhere. It will not stay where I put it, okay? Because the field pressure will move it, okay? Its charge is never going to be neutral, just placing it somewhere.
Yeah.
I mean, there's places that can be stuck because of the fields are trapping it, but I just mean if I don't have an obvious trapping field, an electron will never just stay.
Yeah.
And so the lens would never be a pure lens because it would always be bent whatever way that electron was going. You know.
Yeah. Oh yeah, I should mention, just to bringing up these lensing images and stuff that I stumbled just in some research. I ended up stumbling across the personal blog of this guy who was the head of the NASA image department for a long time, and still works for them. And it's it's very strange, some of the stuff that's written on there, and it's worth taking a look at. I'll link it after this because it's the guy's got these articles that are basically like rationalizing distortions of the imagery.
Well, yeah, no, I think I've seen the website you're talking about. I mean, the websites are just horrible. But yeah, I mean, one of them has a lot of great images. Must be 50 images on it.
Yeah.
But yeah, and there's a real defense of the fact that these aren't real images. And you're almost like you're defending the fact that they're not real images and they're simulations, some of them. What do you mean?
This is
why is a simulation okay? Simulations aren't okay. Sorry, no, you can't do that. Simulations are nonsense.
Well, this is actually this guy's personal blog, but it's that kind of thing.
It has an area of authority. I'm just saying you run across these things, and I'm just saying that they kind of make it sound like it's a real official thing because they're citing their own credentials and their own affiliation. So I'm just saying I was confused by a site I went to, and I thought it was a real government site. And it was Guy's personal blog. He worked for the government, but I'm just saying he wasn't speaking for NASA.
Yeah.
You know what I mean? It wasn't an official site. It was just his official, I'm a defender of this crap site.
Well, they wouldn't have something that pins them down to something,
Yeah, well, see, but like I say, even every one of these conversations will bring up something, and I'll say that's another one thing that's so obvious, right? So it's so why should I have to point out that you can't create a perfect lens, right? That a gravity lens would never be a balanced lens, right?
Yeah.
Now, where else have you heard that?
Yeah, no, I haven't heard that.
Right. No, nowhere. I've read it nowhere. I've seen it nowhere. Not one person has ever speculated about the fact that if you have a gravity lens, it's not going to be like this. It's not going to be an even lens because nothing is in this. There's no center.
Yeah.
You're not in the center of the universe. You're not in the center of the field. So you
Yeah.
can have a balanced lens.
Here, let me just show something here. I'm just going to share my screen for a second. Just this blog thing. Is that screen sharing now? Yeah, here. Of course I'm lying. Trust me. This is the head of the NASA imagery department, and this is actually about that stuff. I just want to just show it so the audience can see that this stuff actually exists.
Yeah.
1auglobalmedia.com. Of course I'm lying. There's no way the images I'm putting on the screen for you can possibly be real. We figured out precisely where the lights need to go, where the cameras need to go, what lens to use, what shade of makeup looks best against the lead actor's sweater. It's all a lie. You think real life looks like this? But he, when you read into the article, he's actually talking about the material that he's working on for the and I just don't know what to think when this guy makes these kind of blog entries. I said I'm lying, but my goal is to tell something truthful. I may lie in the process of doing my work, but my work never lies. Make sure you understand, I'm not intentionally deceiving anyone, but I'm not trying to recreate the real world. I lie to tell the truth. My actions may contrive, but my intention is to speak clearly and honestly through those actions. Creative work never lies. It's always authentic to itself. That it might invent tales to reveal deeper truths about reality is beside the point. You may tell falsehoods in a story, but if the story successfully misleads an audience, the story itself, it's true. This is the head of the...
Yeah, that's like this scary thing, that belief is all that matters, and it doesn't, there's nothing to believe in, so just believe anything, and whatever's popular, it wins.
Yeah.
The truth is whatever everybody agrees it is. No, that's not really the right standard.
Just what he was saying there. I mean, if I would never write something like that.
It's fucking hard to imagine a scientist writing a group like that. It is pretty goofy.
Well, he's not actually a scientist, right? He's just the media department guy. But he's the guy who, is editing and creating the animations and doing all that shit. And this is what he's saying. This guy's obviously got it on his conscience or something. Like, why would you write shit like that? It's fucking weird.
Yeah, I don't know. It is weird.
Anyways, I'll link it in the video so people can go take a look for themselves, because there's actually a whole whack of these completely bizarre and like psycho-babbly kind of articles that this guy's written, and he's really a big guy in that whole game.
So Incomprehensible says, did the universe start with a bang? So they always do this, right? You talk about all this physics stuff, and they always have to go back to what made the first atom, or so who cares? Does it really matter? Big bang, little bang, any bang?
Well, and that's
it's really an important question that needs to be answered in physics. I mean, I think what you need, I don't think you're ever going to have an answer to those kind of questions. Yeah. Anyway, I mean, even if you figure out it was a bang, how are you going to know whether it's a one-time bang or a 5-time bang or a million-time bang?
You can't build a time machine, so you'll never be able to verify the result, and it's always going to be beyond our grasp.
It's footsteps on the sand. I mean, the universe destroys the evidence. Okay?
A billion times
everything we're doing right now is all going to be destroyed. None of this will last. There'll be no statues. There won't even be a rock with a human fingerprint on it, left behind. It's all going to be annihilated by the universe. The universe doesn't leave any witnesses. I mean, it kills all the witnesses.
Yeah. Yeah, if the sun explodes, there's not going to be one single DNA strand left. There will be no trace of anything ever happened here.
Well, you're saying nearly even lens. Gravity falls off at v squared, doesn't go far. The whole point, though, is for the lens to exist, it has to be much stronger gravity than that. So I'm just saying that quite obviously in a field where you're saying there's very strong gravity, there's likely to be influences around that have to also be strong. So I'm just saying that you can't have it both ways. You can't say there's enough gravity to bend light, and yet none of the other influences in the area of the place creating the lens has any gravity. So what do you want me to say to you? I mean, I've already made this argument, but I mean, they're speculating on lenses that are light, hundreds of light years across, millions even. Million light year across lens. I'm just saying the amount of gravity on the edge of a galaxy is like the gravity out where Pluto is in the solar system. It's minute gravity, not strong gravity. And if you were going to lens with a galaxy, you have to lens on the long part of the galaxy. You have to have the galaxy in the flat position to be in the gravity long enough to get lensed. If you're going through the galaxy this way, you're only in the gravity a tiny fraction of the amount of time. So none of their images make any sense.
Yeah. Oh yeah. Speaking of which, I looked up these the sort of numbers or facts on the width versus diameter of galaxies, and the Milky Way galaxy, they say, is 100,000 light years across and 2,000 light years deep. So
right. So 2,000 versus 100,000.
Yeah.
Yeah. Okay. So good. Thanks. It's a pancake. And it's probably the same ratio as a pancake might be bulkier than the galaxy.
Yeah, I think so. It's more like a crepe.
Yeah. It's a crepe. A crepe.
It's a crepe galaxy.
Yeah.
But that's kind of, you don't normally see it really portrayed quite that way. You don't get that sense that it's a crepe, which it is said to be, right? Like it's a very thin, very, 2% of the width kind of thing, like a CD.
Yeah. So clearly, again, if you understand what's causing gravity, you can understand that the gravity multiplies with the mass, and you're going to be affected by more mass going along the edge of the pancake than going through the pancake.
Yeah, it's like a ninja star, actually, when you think about it, because of the arms. We have like these ninja star galaxies.
Yeah, well, they all have the arms, and the arms are the key factor, right? So that's another one where you're just like, man, these guys don't even want to think about anything, right?
I think there's actually
a few talking about the speed problem, and I'm like, well, can't you understand that the arms are the speed problem? I mean, fuck. I mean, it's completely different than a solar system. They're doing solar system math on galaxies, and you're just like, you can't look at the galaxy and see that's not a solar system.
Yeah.
I mean, it has nothing in common with a solar system, and there's just there's no common features between solar systems and galaxies. They're completely gravitationally different objects.
Yeah. Yeah, it's strange. It's hard to.
Yeah, I mean, clearly the mass of a galaxy is in the arms. It's not in the center. It's in the arms.
Yeah.
I mean, I bet you they'll find out that there's a tiny fraction of the mass of a galaxy is in its center.
Yeah, I don't think they're going to figure it out, but
well, they're supposed to have some satellites now, or they're doing some kind of they're creating some space interferometer thing that's supposed to be able to look at the center of the Milky Way and supposed to be able to find our black hole. So they'll see if they find the black hole.
Well, they'll find the black hole. You better
that's the sad part.
I'm sure they're going to find the black hole. Yeah, they're going to spend $1 billion. They're going to fucking find a black hole, damn it.
They'll find it. Yeah, they'll find it.
They're going to find lots of black holes. They've already laid out their plans for all the things they're going to find with more gravitational waves when they put up that, those crazy satellites that are supposed to be at that neutral point between the Earth and the sun's gravity. Or whatever.
Yeah, which is the whole thing is just so stupid. Oh.
Yeah. Well, actually, it just seems like I don't believe that they can build this machine that they say they're building. It seems impossible to me. There are the 3 satellites that go and sync that shoot lasers to each other over 5 million kilometers. That's, and I'm like, well, the width of the beam is going to get huge over that distance. It just doesn't make any sense to me at all. But
well, I don't know if that's going to be the problem. I think.
But you get the inverse.
Getting a true quiet place is the problem. I don't think you can get true quiet. So
I don't think you can shoot a laser beam 5 million kilometers and have it be coherent.
Yeah, I don't think theoretically. I don't know how much laser beams degrade, but theoretically,
Inverse square, same.
no, it isn't.
Yeah, it's just that you start the inverting of the square at a different point than you would with a light bulb. It has, because you get the focus is ahead of where the emitting takes place, but ultimately all light is subject to the inverse square.
No, it isn't.
No, it isn't? Okay.
No, I don't know. I don't believe that. I mean, I think
You think a laser will go? For how long will it go?
I think you can have truly parallel rays of light. That is, rays of light that are parallel.
Well, laser is shooting many rays of light, right? It's not
Right,
shooting.
right. I'm just saying, but a laser, that's the whole function of a laser, is that when you say it's coherent, that the point is it's coherent essentially means parallel.
Well, I'm saying that the
unlike,
overall beam is going to not be coherent, not each ray. I mean, I'm just saying I don't think there's going to be enough laser to pick up after 5 million.
I know, but space is really kind of empty, so there's nothing degrading the photons.
No, it'll just get too wide.
Look, if photons can get all the way here 15 light years away, right? 15 billion light years away.
Yeah, not in laser beam form. Okay,
well,
whatever.
I say it doesn't matter. It's a photon. My point is a photon gets here.
Well, I'm not saying no photons
well,
will get
I'm just saying. So it's not that far for a laser beam to travel through empty space. That theoretically there still should be a lot of value undestroyed. The only thing you can do is destroy the photons, right? You can't get rid of them any other way. You have to destroy them. You have to hit an electron.
Okay, well, it's 5 million kilometers. I'll do the math on it, and I'll
5 million kilometers is not that far, right? I mean, the sun is like whatever.
I think it is for a laser. I'll look into it. I'm not going to argue it without having actually done the numbers on it, but whatever.
I'm just saying the only thing that can degrade it is the same thing that degrades light traveling 15 billion light years.
Yeah, but it's not light. We're not talking about rays.
Again, we are. It's all rays. They're all photons.
But I'm saying that it's a laser beam that they're going to receive at the other end.
Yeah, it doesn't. I'm saying if well, whatever. There's no point in me saying it over and over and over again. I'm saying that it's not nearly enough distance to degrade the amount of photons that are being released. And they're all being released they all go one place. They don't spread out. So there's no divergence. Without the divergence, right? Without the spreading, there's no weakening.
They do spread out.
They don't. The whole function of a laser beam is not to spread out.
No, they do spread out eventually. You think? How long do you think it'll go? 10 billion light years?
They spread out, but I'm just saying that. Let's see. It's like let's see how to.
I know for a fact that they.
I mean, obviously, if I shine a laser pointer against my wall, 30 feet away, the spot on the wall is bigger,
right,
than the spot is at 2 feet away.
Exactly.
So obviously, there's some spreading. So I'll concede that, but that's a laser pointer. It's not a really great laser.
Yeah, but it's 5 million kilometers.
Well, I'm just saying, if it's a really good laser and the light actually is coherent, there's absolutely no reason to think that you can't have less spreading and therefore no divergence. But
okay, well,
a laser beam isn't still doing it at the same rate. The divergence built into a laser isn't anywhere near the same divergence because it's not doing the pinpoint spreading. You know what I mean? It's not spreading by the geometry of a sphere. So it still is an inverse square. It's some other relationship of its degrade.
No, it's still
not
the
inverse square unless it's a spherical. It has to come from a pinpoint and be spherical to be inverse square.
Well, you know what? I know how to figure out how to do the math. So I want to make my counter argument after I've actually had the opportunity.
Well, I'm just saying that you can kind of intuitively understand it. I'm just saying that.
Well, yeah, I have a.
You have to have that 180 degree angle thing. You have to be spreading exactly at the peacock kind of angles. You know what I'm saying? To do the inverse square thing. So I'm just saying, as soon as you start narrowing that angle, you change the inverse square into a different square.
Yeah, I don't know. I'll look into it.
But it is a good point whether they have a laser that can be coherent enough to survive that kind of distance.
The good thing about this is that if I take the time, I can just find the way to calculate it, and I can just make an estimation about the distance, because or I can figure it out based on numbers. I can actually plug the numbers in. So I'll do that at some point.
Yeah, I'm just saying there's no numbers to plug in if they can actually make a coherent laser. I'm just saying that the only thing a laser
that's where I disagree.
The only thing a laser pointer is indicating is they're using a crappy lens to, augment the function of the laser, so it's not really coherent light. So I'm just saying that the pointer lasers aren't good enough lasers.
I don't think perfect laser beams exist, personally. I think there's just going to be there's some.
No, I think in
it's
theory.
okay. I don't want to argue about this anymore. I'm going to look into. I don't want to make a counter argument without actually knowing what the real deal is about this stuff.
Yeah, well, I think it is possible to create light that is parallel. So yes, parallel light's not going to diverge. And
okay, but so there's no limit then?
The limitation, again, is the amount of electrons in space to destroy the photons. So yes, the limitation is still you're moving through a medium that has some mass in it that will eat your photons. But theoretically, as the photon that makes it all the way across the universe points out, theoretically, yes, there's no limit. The photon, as long as it's not destroyed, can make it to a target.
I just don't think it's spreading at zero angle. I just can't imagine that could be possible.
Well, I'm just saying, I think it's possible in the sense that if you do have, like, say, if you magnetically control the electrons and they're all in the same position and then they all emit light from the same geometric position, then it'll all be coherent light.
Yeah, I don't think they can do that.
Well, I'm saying that I think that's the function of lasers, are technically doing.
But they're not perfect.
I know. Well, I'm just saying that I think they probably have a laser that's a lot better than the ones I'm used to. So I'm just saying that I think they probably do have lasers. I mean, they have lasers. Obviously, they can shoot to the moon and back. And
well, how many photons are making it back? I mean,
a lot of them make it back. A lot of them.
I don't know that they have that. What they say so. Well, I don't know. I don't take that.
Well, you don't think they do that? They do it all the time. That's they.
I don't have any evidence that they
shoot it and then they collect it with a telescope. But yeah, it's
right. Well, and it's NASA, and then they say, "Yeah, we did it," and that's all I have to go on.
Well, what, you don't think that one's theoretically possible? And
I think it's possible. I just don't know that they're. I'm not going to assume it's
100,000 miles away or whatever.
But why would I assume it's true from liars?
Well, I'm just saying it's silly to say that they're lying about the shoot.
They lie about other stuff.
Well, I'm just saying now you're back to conspiracy theories.
No, it's not a conspiracy theory.
I'm sorry. That one is. It's not a fucking complex experiment. Why would they lie about a non-complex experiment?
Well, for the same reasons that they would to support their
they can't even lie about it because it's used for a technical purpose. I mean, they use it for alignment purposes to tell exactly how far the moon moves and everything else, and they couldn't do that without it. So I'm just saying it's quite obvious, in my opinion, that they've done it.
Okay. Well, I don't trust them as much as you do, I guess. That's what it comes down to.
I'm just saying they're pretty good at some of that technology. They fucking landed on the goddamn moon. Newsflash, it did happen.
Well, I'll tell you, NASA has some fake videos, and I can prove it. And so
you can't prove it.
Yeah, I can.
No, you can't.
Okay. Well, you're not going to hear you don't want to hear the
Well,
argument.
go ahead. Yeah, point me to the videos of the faked evidence, NASA faked evidence. Go ahead. Okay. Show me the fake videos of the moon.
I'm not saying the moon. I'm saying they have fake videos.
Fake video of what?
The various things, the space station and the shuttle. And
yeah, right. Light coming out.
I'll bring it up. I found one. I know it's fake.
Off the glass. I mean, I've seen this crap. Well, don't you understand? This is just
no. You haven't seen this crap because this is my crap that I found.
Okay.
No, it's not crap.
Photos of the airplane, and you can obviously see the shadow of the bombs on the airplane.
Whatever. I can prove it.
Well, you say prove. I just it's a bold statement, a bold fucking statement.
Okay.
You want to stake your reputation on it? Do you really want to stake your fucking reputation on it? Because if I bother looking and I prove it to be absolute shit, then you become an untrustworthy source. So do you want to fuck your reputation over this shit?
Yes.
Okay, then go ahead and do it. Go
ahead.
Give me the goddamn fucking links then, and we'll be done with this. I won't have to listen to you ever again, because this is just such crap.
Okay.
I mean, you become a useless source when you sit there and can't distinguish between goddamn evidence that means something and evidence that's crap and weak.
So what are you going to stake on
And I'm
this?
sure your evidence is crap and fucking weak.
What are you going to stake on it?
My same reputation, jackass.
Okay.
I can't tell a pile of shit when I hear it.
Okay, I don't think you should do that, but if you want to.
Yeah, no, I'm fine with that. That NASA faked goddamn images to prove what? Nothing. To do absolutely nothing of value.
Well,
now, you want to say that NASA faked its fucking arsenic biology experiment in the sense that the scientist was an idiot? Fine. You want to say NASA made a mistake somewhere? Fine.
No.
But you gotta sit there and tell me they have deliberately contrived fake evidence.
Yes, I.
Okay, go ahead. Prove it, then. Prove it.
Fucking thing.
Prove it.
Watch the video.
Prove it. Okay, get the fuck out of here. Give me the link to the fucking video and get the fuck out of here. Truth or Coke?
Okay, you're gonna.
Fuck off. Jesus. This is why people from the outside can't get anywhere, is because most of the outsiders, most of the people saying, hey, they might be tricking us, they might be wrong, they might be ignorant, are always some kind of kooky conspiracy nut. Some fucking asshole who has to make it into a bigger story than it is, has to come up with a bigger lie. Oh, they're trying to trick us. Oh, they're programming us. Oh, they're doing this. They're fucking Martians. They're fucking reptilians. 9/11 was an inside job. I mean, it's just so fucking irritating. Useless shit. I mean, it gives everybody who is a little bit skeptical, a little bit who wants to challenge the authorities, it gives them all a bad name because of these assholes who have to do their stupid fucking conspiracy crap. They're not idiots, they're liars. Proof. Yeah, right. No, the moon landing wasn't fake. Well, I mean, the part of it was fake in the sense that they actually walked on the moon, set up the camera, okay, then they pretended to walk on the moon. You know what I'm saying? I mean, Armstrong's first step on the moon wasn't Armstrong's first step on the moon. He'd already stepped on the fucking moon. All right. He'd already done his leap for mankind thing, and they just reenacted for the camera. But yes, they did land on the moon. Oh, shit. But anyway, this is just gives you no hope for any kind of reason in the world because people would just keep jumping on the unicorns. So anyway, probably enough. Till next time. I'll go wait and find wherever he's going to post his fucking link to his proof. Fuck. So, till next time and such.